Welcome to Introduction to Software Programming and Databases. Are you interested in learning the basics of software programming languages? Does finding out more about software development, cloud computing, web browsers, and their security features appeal to you? Would you like to get more information about databases and their fundamentals? Ever wonder how to organize code in the easiest, simplest, and most efficient way possible? If so, this course is for you. During this course, you will learn about the basics of software development technologies and programming languages. This course introduces the basic concepts of cloud computing, and you will gain hands-on experience identifying file formats and installing and uninstalling browser extensions and plugins. During the course, security and development related to web browsers, applications, and content will be discussed. You will also discover how to identify types of databases, how to access and manage data, and identify the 4 types of backup methodologies. In addition, you will learn how to organize and plan software programs using flowcharts and pseudocode. This course is divided into 4 modules: Computing Platforms and Software Applications, Fundamentals of Web Browsers, Applications, and Cloud Computing, Basics of Programming, and Fundamentals of Databases. The Computing Platforms and Software Applications module provides information about computing platforms, including single and cross-platform software. You will discover the differences between commercial and open source software while also exploring software versions, compatibility, different types of software, and file formats. In the Fundamentals of Web Browsers, Applications, and Cloud Computing module, you will learn about common web browsers and browser settings, security, extensions, and plugins. You will examine cloud computing and learn about application architecture, delivery models, and software development lifecycles. The Basics of Programming module will give you a solid foundation of basic programming concepts and programming language categories. You will explore basic programming logic components and how to organize software using flowcharts and pseudocode easily and quickly. Throughout the Fundamentals of a Database module, you will learn about basic database concepts, types of databases, and how to use and manage databases. You will also learn about interfacing with a database and backing up a database. To successfully complete this course, you should be familiar with basic computer operating skills and terminology. Additionally, knowledge of how to use a modern web browser like Google Chrome is required to complete this course and the hands-on labs within it. Finally, you will need to create a free trial account for IBM Cloud. We're here to support your success, and we're excited that you're here. Let's get started. Welcome to Computing Platforms and Compatibility. After watching this video, you will be able to define computing platforms, identify single and cross-platform software, and identify cross-compatibility issues. What are computing platforms? A computing platform is the environment where the hardware, like your personal computer, and the software, like your operating system or OS, work together to run applications. Hardware refers to the type of computer or device, such as a desktop computer, a laptop, or a smartphone. Software, in this instance, refers to the type of operating system, such as Windows, Mac OS, iOS, Android, and Linux, and also includes the programs and applications that run on the OS. Here are 3 types of common computing platforms. The desktop platform includes devices like personal computers and laptops that run operating systems like Windows, Mac OS, and Linux. The web-based platform includes browsers like Firefox and Chrome that function the same in various operating systems, regardless of the hardware. The mobile platform includes devices like the Pixel and the iPhone that run operating systems like Android OS and iOS. When planning applications, software developers must consider if they will be designing for one platform or across platforms. Depending on who the primary users of an application will be, software developers design either single-platform software, meaning that the programming code only works on one kind of computing platform, or cross-platform software, meaning that the programming code will work on multiple platforms. Here are some of the differences. Single-platform software is written for a particular OS or version of OS. It may also be written in a programming language like Java or Objective-C, which is specific to the platform. Additionally, single-platform software is designed to run only in the target OS and most likely won't run as intended on other platforms. Some developers use applications like Xcode for iOS and Android Studio for Android to code single-platform software. However, cross-platform software is different from single-platform in several ways. It is written for more than one type of OS. Applications across devices and operating systems operate the same or similarly regardless of the computing platform. Performance of the software varies due to platform differences. And some developers use applications like React Native and Xamarin for cross-platform software development. Before creating a single-platform or cross-platform application, developers must weigh the pros and cons. Let's look at some single-platform pros first. An advantage of single-platform software is that the software has a smaller, more focused app user base. Single-platform applications have better performance and faster speeds because they are running on their native platform. Also, the programs are normally easier to use because the user interface is designed for one specific OS. However, there are also some cons. With single-platform software, there is a higher cost of development because the application must be made specifically for one OS. Single-platform software also has a longer development time since the code must be uniquely written for the platform. Additionally, more specialized programming expertise is needed, which means higher costs for the software development. And updates and maintenance are higher due to the unique programming knowledge needed. Now let's look at cross-platform software. Some pros are lower cost of software development, which can happen over a shorter time. Another advantage is a wider app user base and market reach because the app is available on more devices. Additionally, programming expertise is more generalized because developers do not need to learn specialized operating systems, and they are able to use the same coding. Also, updates and maintenance are more readily available and affordable. Cons include the following. Cross-platform applications have design challenges for making the software function similarly and correctly in different operating systems. Performance and speed may vary due to differences in platforms. And the user interface may also vary and be less reliable across platforms. So, these are only a few of the key factors that developers should weigh when deciding what is best for their software and for their user base. When considering cross-platform software, it's important to realize that there are some compatibility concerns. Be aware that cross-platform software acts differently depending on the platform and may even have limited usability. It's important to remember that cross-platform software is created by different developers most of the time. This means that programs may interpret the code differently in each application. Functionality and results can differ between platforms. Sometimes these differences can mean undesired results and errors. Other times, it can just mean a difference in appearance or how the software is accessed. This could happen when a document is created in Microsoft Word on a desktop PC. Then the document is edited in Google Docs through a web browser, and then it is opened on a mobile device. As the document goes through this process, several different applications are being used. This results in a change in appearance in the document and sometimes a change in how the document is used. In this video, you learned that single-platform software is developed for one particular operating system. Single-platform programs are more focused on the user base, are faster, and have a better user interface. However, single-platform programs are also more expensive and take longer to develop, require more specialized programming expertise, and need more ongoing maintenance. Cross-platform software is developed to be used across different platforms, and it should function the same or similarly on different platforms. Cross-platform programs are less expensive to develop, have a wider user base, require more generalized programming knowledge, and have more readily available updates. However, cross-platform programs also have more design challenges, have varying performance and speeds, and sometimes have user interface issues across platforms. And compatibility concerns arise when a software does not function similarly or correctly across platforms, and when the same options and commands are not available across platforms. Welcome to Commercial and Open Source Software. After watching this video, you will be able to define commercial software, define open source software, and identify differences between commercial and open source software. So, what is commercial software? Commercial software, also sometimes referred to as proprietary or closed source, is copyrighted software. When individuals or companies purchase the software, they must acknowledge the software developer's copyright, which is identified in the End User License Agreement, or EULA. Commercial software source code is private, and users are prohibited from copying, modifying, or redistributing the software or any part of the source code, except parts of the source code that may be open source. It is usually developed for commercial profit and can include open source code bundled with private source code. When commercial software is installed, a product key or serial number is issued to certify that the software is original. Some commercial software is free, but upgrades and updates may cost extra, or the software may contain ads. Some examples of commercial software are Microsoft Office, Adobe Photoshop, and Intuit QuickBooks. Software licenses are also required for most open source software. Open source is also referred to as free and open source, or FOSS. Open source software is free and can be downloaded, installed, and used without limits or restrictions. Note that free software is not always the same as freeware, which is free to users but is not always open source. Open source software contains free source code, which can be freely copied, modified, and redistributed. It also gives developers and users open access to the functions of the software and source code without the cost or restrictions. A benefit of open source software is that developers and users can contribute to the source code and work together to improve the software and its functionality. Even though open source software is free and open, users are still required to agree to an End User License Agreement, or EULA, in order to use the software. Some examples of open source software are Linux, Mozilla Firefox, and Apache OpenOffice. There are some important differences in open source and closed source software. With open source software, the source code is available to be edited, modified, and redistributed. Users don't have to pay to download, install, or use the software. Open source code can sometimes be used in commercial software, which is usually developed for profit, but can also include freeware. With closed source software, developers keep private the source code and how it works. Additionally, with closed source, a company or individual owns the rights to the source code and software, like with Microsoft Edge web browser. Freeware, like the Edge browser, and commercial software can be closed source, regardless of whether it is available for free or for purchase. The Chromium web browser is an example of open source software, and the source code is free and openly available to everyone. The basis for the code in the Microsoft Edge web browser is from the open source code in the Chromium web browser. While some of the source code in Edge is open source, most of the source code is closed source and proprietary. The Microsoft Windows OS is both closed source and commercial, and users pay for the software. Note that for all software, whether it is open source or closed source, anyone who wants to use the software must agree to the End User License Agreement. So, how can you tell the difference between open source and closed source software? Most software has an About section located in the details of the software. If there isn't an About section, look for details or some terms that are similar. In this example from the Microsoft Edge web browser, you would select the three dots in the right corner. Next, from the list, you would select Help and Feedback to open more options. Then you would select About Microsoft Edge for more details. So how do you know if the application is open source or closed source? Once you select About Microsoft Edge, the details show that Microsoft Edge uses Chromium open source code and other open source software. While the steps for determining open source or closed source will not be the same for every application, you can follow similar steps to find more information. Or you can search trusted websites for more information about source codes for most software. In this video, you learned that commercial software is also known as proprietary or closed source software. Commercial software is copyrighted software. Individuals and companies can purchase commercial software as long as they comply with the specified conditions listed in the software license. Commercial software contains private source code that is often not accessible to users and competing companies. Users may not copy, modify, or redistribute private source code from commercial software. Additionally, you learned that open source software is also known as free and open source software, or FOSS, and it can be downloaded, installed, and used without limits or restrictions. The source code in open source software is free and can be copied, modified, and redistributed. Users and developers have open access to the software functions and source code. There is overlap between open source and commercial software because open source code can be used in commercial software. All open source software is available for free, and some commercial software can be available for free. And finally, you can find out whether software is open source or closed source in the About details of the application or program. Welcome to Software Licenses. After watching this video, you will be able to define software licenses, identify types of software licenses, and identify product keys for activating software licenses. What is a software license? A software license states the terms and conditions for software providers and users. It is a contract between the developer or group who created the source code and the end user of the software. It specifies who owns the software, outlines copyrights for the software, and specifies the terms and duration of the license. It states where software can be installed, how many copies can be installed, and how it can be used. It can be lengthy and full of definitions, restrictions, and penalties for misuse. Agreeing to the licensing terms is required for use of most software. If you want to install and use software, you must agree to the terms and requirements, which is called an End User License Agreement, or EULA. Agreeing to the EULA means that you accept the terms of the license, such as how many computers the software can be installed on, how it can be used, and what the limitations on developer liability are. Different software programs and applications have various ways of presenting their EULAs. Let's look at some common examples of types of licenses. Single-use licenses allow a single installation on one computer, or, depending on the software, the license may allow a single user to install the software on any machines that belong to the user. A group use, corporate, campus, or site license allows multiple installations for a specified number of users. It also allows installation on many computers or devices. This kind of license is ideal for use with computers and devices that are registered to a group, such as a computer lab on a college campus or a writing team at a newspaper. Concurrent licenses allow installation on many computers, but they can only be used concurrently, meaning at the same time by a lower number of users. It allows many users to have access to the software, but it is not used often by a lot of people at once. Concurrent licenses are ideal for companies that do not have all workers using the software at the same time, such as nurses and doctors who work different shifts. Now, there are some differences between open source and proprietary software licenses. Open source licenses, also referred to as free and open source, or FOSS, are still necessary for open source software to protect developers and contributors. Proprietary software licenses are more restrictive and are designed to strictly protect the software developer and those who invested in the software. An open source license means free software which can be downloaded, installed, and used without limitations or restrictions. Free source code which can be freely copied, modified, and redistributed. However, open source software will still require users to sign a licensing agreement, even though there are no limits or restrictions. Proprietary software licenses aim to protect the developers and the companies who own the software. Proprietary licenses cover copyrighted software with specified conditions listed in the license. Proprietary licenses also protect private source code, which users are not allowed to copy, modify, or redistribute. Users are also required to sign an End-User License Agreement, or EULA. How much does a software license cost? Costs vary depending on the type of software, how it will be used, and how much was spent to develop the software. Remember that the cost is for the software license, which allows you to use the software. Several options are available, such as trial, subscription, and one-time purchase. Trial licenses are available, usually for free and for a limited time, to allow a user to decide if they like it and want to purchase the software. Subscription and one-time license purchases are also available. The software description will identify whether it is either subscription or one-time. Subscription licenses require recurring payments, and users are billed regularly on a set schedule such as monthly or yearly. Software developers and companies often prefer subscription-based models because they generate more income, and they allow developers and companies to control the cost and updates for the software licenses. Subscription-based licensed software can be used offline, but online access is needed from time to time for updates and upgrades. Also, online access allows users to verify with the vendor that the subscription is still active. Users can access the software for a limited time as long as their subscription is valid. If users do not verify their subscription, the software might not be available to them. Conversely, with one-time license purchases, users pay just once for the software. A one-time purchase of a software license also means that the application or program can be used without interruption for the life of the software. However, a drawback to a one-time purchase is that updates or upgrades to the software may not be available, and the user will need to purchase newer versions or upgrades separately. Both have their advantages and limitations. It is up to the user to determine which purchase is the most appropriate. To ensure that the software that you are using is licensed, developers and vendors will issue a product key when software is purchased. Product keys are unique long sequences of numbers that certify that the copy of the software is original. Product keys are usually included on a physical copy of the software or sent through email when the software is downloaded. Some programs and applications automatically register the product key when you install the application. For subscription software licenses, serial numbers or license IDs may be used. When software is activated, the product key is locked to a specific computer, which helps prevent piracy of software. In this video, you learned that a software license states the terms and conditions for software providers and users. It states where software can be installed, how many copies can be installed, and how it can be used. When installing software, users are asked to agree to the End-User License Agreement, or EULA. Single-use licenses allow a single installation on one computer. A group-use, corporate, campus, or site license allows multiple installations for a specified number of users. Concurrent licenses allow installation on many computers, but the number of users at the same time is limited. Additionally, open source software or free and open source software, otherwise known as FOSS, is free software which can be downloaded, installed, and used without limits or restrictions. Open source software contains free source code, which can be freely copied, modified, and redistributed. Proprietary commercial or closed source licensed software indicates that the software is copyrighted with specified conditions listed in the license. Proprietary software source code is private, and the license prohibits users from copying, modifying, or redistributing the software or any part of the source code. Costs for software licenses vary depending on the type of software, how it will be used, and how much it costs to develop the software. Product keys are unique sequences of numbers that certify the copy of the software is original. Software licenses and product keys are in the program or application after it is installed on your computer. And a product key locks with a specific computer, which helps prevent piracy of the software. Welcome to Software Installation Management. After watching this video, you will be able to discuss installing and uninstalling software on various computing platforms, and identify software installing and uninstalling best practices. Consider the following before installing software. Read the application details and be selective about what you're installing. Be aware that some software may also install ads or other unwanted software. Avoid downloading software that contains malware designed to steal personal information on your device, encrypt your files, require you to pay a ransom for decryption, or monitor your device. Review permission requests to access other apps and hardware on your device. And be selective when allowing application privileges to items such as your device's camera, contact lists, location data, and similar sensitive information. Before installing software, you should consider what will work best with your project and what will work optimally on your device. You should consider minimum system requirements such as minimum processor speed, minimum amount of RAM, the minimum amount of hard disk space available, and compatible operating system versions. Additional requirements may be a specific display adapter, the amount of display adapter RAM, and an internet connection to use the software. Windows desktop software will usually have an installer. To install software from physical media, such as a USB or CD, insert the disk or drive and wait for a prompt to run the installer. Sometimes the installer will run automatically. If the installer does not start automatically, browse the file system for the software. Locate the installer, usually an EXE or MSI file, and then double-click to start the installer program. When installation is complete, the application should start. You can also download and install software for Windows. Software downloads are available through Windows-compatible websites or from the Microsoft Store. When installing software from a website, be sure to verify that the site is trustworthy and read installation prompts. Do not install any software from a site that looks suspicious. Many installers, when started, will automatically begin installing the program or will guide you through the installation process. And programs available for download are available as compressed files, EXE files, or ISO files. You can also install software from a disk in macOS. To install software from a disk, insert the disk in the computer, and the setup utility should start automatically. If setup does not start, you can use Finder to browse for the disk to start the setup. In Finder, locate the setup file. To start the setup, select the file and then follow any prompts. To install macOS software that you have downloaded from online, open the downloaded file and then follow the installation prompts. Locate the file you have downloaded, which may sometimes appear in the bottom corner of your browser after the download is complete. If you did not download the software from the Apple App Store, you might receive an alert that says the application cannot be opened. If you're sure the software is safe, then select Open to continue the software installation. Mac installation files have several different file formats, including zip PKG, and DMG. For a zip file, double-click the file to install it into its own folder. Within that folder, you will find a PKG or DMG file. PKG files will install the software automatically, and DMG files may need to be moved into the Applications folder. Most operating systems have their own online store from which you can download and install programs. In the vendor store, you can browse for applications, select one, and then select Install, and the application will start downloading from the online store. Be sure to read the prompts from your device before uninstalling any programs and applications. Here are some reasons you might want to uninstall software. The software slows down your device. The software version on your device is outdated, or there is not enough available storage space on your device. Follow these steps to uninstall software in Windows. Navigate to Settings on your computer and then select Apps. From the Apps and Features list, select the application and then select Uninstall. And if prompted, verify that you want to uninstall the program. If you are using a more modern version of the Windows OS, such as Windows 10, you can uninstall a program or application from the Start menu by selecting the app tile and selecting Uninstall from the menu. Be sure to read any warning messages or prompts about uninstalling the software. Steps for uninstalling software on Mac OS devices depend on which version of Mac OS you are using. However, most uninstalling processes require the same or similar steps. To uninstall software in Mac OS, move the file or icon from the Applications folder to the trash, which is located on the dock, and be sure to empty the trash to make sure the application is removed. In this video, you learned that you should read the application details and be selective about what you're installing. You should view your minimum system requirements to determine which software and versions will work best for your project and what software will work optimally on your device. The process for installing software varies depending on your devices and operating systems. You should read and follow the setup instructions when installing new software. And for some software, you might need to perform several steps before uninstalling the software. For most modern software, you might only need to select the app and then uninstall. Welcome to Software Versions. After watching this video, you will be able to discuss software versions on computing platforms and identify software versions and numbering. Software versions tell us a lot about programs and applications. Users can determine what software version they are using, and developers can provide useful information with version numbers. Software version numbers vary in length and meaning. However, most version numbers follow a similar format and represent similar information. Version numbers indicate when the software was released, when it was updated, and if any minor changes or patches were made to the software. Software versioning is how software developers keep track of new software, updates, and patches for programs and applications. Version numbers can be displayed in several ways. Version numbers can be short or long depending on the software and the preference of the developer with 2, 3, or 4 number sets. Each number set is divided by a period. The first release of an application or program might have a 1.0 as the version number to indicate no updates, patches, or fixes to the software. Note, a version still in beta or testing could have a version number lower than 1, such as 0.9. A program or application with many releases and updates will have a longer number, sometimes 4 different number sets within the version number. Some software developers may use dates for their versioning. For example, Ubuntu Linux version 18.04.2 was released in 2018 April. The third number set, .2, designates an additional change or update. What do these numbers mean? Some version numbers follow the semantic numbering system and have 4 parts separated by a period, but not all numbering systems follow this 4-part example. In semantic numbering, the first number indicates major changes to the software, such as a new release. The second number indicates that minor changes were made to the software. The third number in the version number indicates patches or minor bug fixes. And finally, the fourth number indicates a build number or build date, and it can indicate less significant changes made. Software version numbers are identified in the About or Help section of software. You can practice identifying your version number in a web browser. This example illustrates how to view the version number in the Google Chrome desktop web browser. However, if you are using a different web browser, you should be able to follow the same or similar steps. To view the web browser version, first select the 3 dots or 3 lines in the top right corner of your browser. Next, select the menu item, Help, then select About to view the version information. The version of your web browser will display. Are newer versions of software compatible with older versions? Lack of compatibility between old and new versions of software is a common problem. You can troubleshoot compatibility issues by viewing the software version to determine if you are using an outdated version of the software. Sometimes updating software to a newer version will resolve compatibility issues. Some software is backwards compatible. If a program or application is backwards compatible, then the older versions of files, programs, and systems will work properly with newer versions. In this video, you learned that version numbers indicate the history of changes, updates, and patches to software. Some version numbers follow the semantic numbering system and have 4 parts separated by a period. Compatibility with old and new versions of software is a common problem. And you should view the version of the software you are using to determine software compatibility. Welcome to Productivity, Business, and Collaboration Software. After watching this video, you will be able to identify productivity software, define business software, and recognize collaboration software. 4 of the main types of software are as follows. Productivity software enables users to be productive in their daily activities. Business software is related to work tasks and business-specific processes. Collaboration software enables people to work together and communicate with each other. And utility software helps manage, maintain, and optimize a computer. It's important to note that a program or application can be categorized as multiple types of software. For example, most business software also falls into the productivity and the collaboration software types. What is productivity software? Productivity software is made up of the programs and applications that we use every day. This software can help manage activities and complete daily tasks. There are many types of productivity software, and here's a list of a few of them. Word processing software is employed to create, use, and edit documents. Some common examples are Microsoft Word, Pages on the Mac OS, and Google Docs. Spreadsheet software is used to create worksheets that perform calculations on data, such as statistics and financial information. Some common software examples are Microsoft Excel, Numbers on Mac OS, and Google Sheets. Presentation software helps users create slides for presentations, meetings, and gatherings. Most people are familiar with Microsoft PowerPoint, but Keynote and Google Slides are also common. Web browser software includes Google Chrome, Microsoft Edge, Mozilla Firefox, and Safari. Web browsers connect users to content on local networks or on the internet. You're probably watching this video, taking this course on a web browser right now. And finally, visual diagramming software helps users with creating, using, and editing visual files such as drawings, artwork, and photos. Examples of visual diagramming software are Adobe Photoshop, Adobe Illustrator, and Microsoft Visio. What is business software? Programs and applications that help businesses complete tasks and function more efficiently are considered business software. Some business software is uniquely designed to meet industry-specific needs. Some of the common types of business software are as follows. Database software can help businesses create, manage, and maintain databases. Some examples of database software are Microsoft SQL Server, MySQL, IBM DB2, Oracle Database, and Amazon RDS. Project management software is useful to help build, implement, track, and manage projects. Examples are Microsoft Project, Oracle NetSuite, Rike, and ZenHub. Business-specific software applications are created for businesses depending on their specific needs. Some companies might need a special application to perform essential business duties. Examples are Salesforce and Oracle NetSuite, which are customer relationship management or CRM systems, and WorkWise and SAP HANA, which are both enterprise resource planning or ERP applications. Another business software type is accounting software, which is used to track and manage financial transactions and records. Examples are Intuit QuickBooks, Xero, and FinSync. What is collaboration software? Collaboration software helps people and companies communicate and work with each other. Some collaboration software can be classified as business software also, but the two are not interchangeable. The primary purpose is to help users create, develop, and share information collaboratively. There are 5 common types of collaboration software. Email clients are used to send and receive emails. Common examples are Microsoft Outlook, Mail for Apple devices, and Gmail. Conferencing software connects users through video call, chats, screen sharing, and file sharing. Cisco WebEx is a popular example, but recently Microsoft Teams and Zoom have become a lot more common. Instant messaging software connects 2 or more users in real-time texts and sometimes video. Examples are Facebook Messenger, Snapchat, and Skype. Online workspaces provide an online space for services and applications, for file saving and sharing, and for working together. Examples are Microsoft Office 365, Slack, and Google Docs. And document sharing software hosts private and shareable file storage by cloud-based services. Examples are Microsoft OneDrive, Google Drive, and Dropbox. What is utility software? Utility software runs continuously on a computer without requiring direct interaction with the user. These programs keep computers and networks functioning properly. Some types of utility software are as follows. Anti-malware software scans the computer and individual files for malwares like viruses, spyware, worms, and trojans. Anti-malware looks for suspicious patterns of computer code. Once a threat is identified, the anti-malware software removes it or quarantines it. Examples are Bitdefender, McAfee, and Norton Antivirus. Firewall software protects users from streams of network traffic that could harm their computers and networks. Some of the methods firewalls use to control traffic in and out of a network are packet filtering, proxy service, and stateful inspection. Some examples are Windows Firewall, pfSense, and Cisco Secure Firewall. And preventative maintenance software runs scans, checks, and diagnoses hard disks for errors. Some software also optimizes the performance of the computer. Some examples are Windows Disk Management, Check Disk, and Optimized Drives. Software usability. Most software is cross-platform software that runs on Windows, Linux, and Mac OS machines. Software applications are installed from a disk, flash drive, or downloaded from the internet, and then they are activated using the product key. Some commercial software, like Adobe Photoshop, Oracle NetSuite, and Intuit QuickBooks, can be purchased from the vendor and activated via a product key or activation key. In this video, you learned that productivity software like Microsoft Word and Adobe Photoshop helps users manage tasks, email, documents, projects, and activities. Business software such as Oracle NetSuite and Intuit QuickBooks helps people and companies complete business tasks. Collaboration software like Slack and Microsoft Teams enables people to work together and communicate with each other. And utility software, such as McAfee and Cisco Secure Firewall, keeps computers and networks functioning properly. Welcome to Types of File Formats. After watching this video, you will be able to list common file format types and identify common types of files by their extensions. Knowing the format of a file helps you determine which application is needed to open or run the file. Some common file formats are executable files, compression files, audio and video files, also known as media files, image files, and document files. You can identify the file format quickly by the file extension. File extensions tell users more information about files and the applications that use those files. They can do several different things. File extensions are identified by a period followed by a 3- or 4-letter extension or suffix. The extension tells the operating system which applications will run the files. The extension appears after the file name. In Windows applications, the extension will usually indicate what application will run the file. And they can indicate the file type, such as executable, compressed, or image. Executable files run programs and applications. The executables may be part of the operating system, an installation package, or an application that runs on the computer. Being familiar with the types of executable file types is important so you understand what will be running on your computer. Some executable file formats and extensions are as follows. EXE are Windows applications that may have several files with them that help them run on the computer. BAT files are batch files or scripts and include a list of commands that the computer must execute in sequential order. SH files run shell commands and scripts that are executable on Linux or Unix, which are equivalent to Windows BAT files. CMD are command files for Windows. They are also script files and contain commands that are completed in order. They are similar to BAT files. App files are a type of Mac application bundle, and MSI files are installer packages in Windows. What are compressed file formats? Compressed formats, also called compression formats, are used as follows. Combining files to save disk space. The most popular compression format in Windows is zip, and file compression is often discussed as zipping files or as zipped folders. Storing archived files, like old emails that might not need to be accessed regularly but should still be kept. And condensing any type of file, including media files. Common compressed formats are as follows. Zip or ZipX is a compression format for Windows computers. 7-zip or 7z is used for the 7-zip archiver. gzip or gz is the default format for the gzip compression utility. ISO is a file system that uses writable CDs and DVDs or USB flash drives to create an optical disk image. JAR is a format for compressing Java class files and data. RAR is a format for the WinRAR file archive program. And TAR is a tape archive. What are audio and video formats? Audio and video formats are media files that can contain sound recordings, video recordings, or both. Audio files such as voice recordings, podcasts, music, and audiobooks are saved in audio formats. Video files such as movies, TV shows, video presentations, and music videos are saved in video formats. And because different media players support different media format files, it's important to know which format you have. Audio and video formats are sometimes listed together and sometimes share the same extensions. This is because they often share the same properties or have both video and audio data in them. Common audio files include WAV, MPEG, which includes MP3 and MP4 file types, AAC, and MIDI. Common video files include AVI, FLV, MPEG, which includes MP4 and MPG, and WMV. Images, photos, digital paintings, and pictures can be stored as image files. The BMP format is an older file format, but it is not used as often due to large file size. The GIF format can store and cycle through several graphics in one file. JPG or JPEG have smaller file sizes, but also have lower image quality. PNG has higher image quality than its predecessor, GIF. And TIFF or TIF saves images in a high-quality format, but the images do have a larger file size. While these are not all of the image formats, these are the most common. Files that rely on mostly text are saved as document files. Some document formats are as follows. TXT or text files are plain text with no formatting. RTF or rich text format is a word processing format used by most of the common word processing applications. It includes basic text formatting, headers and footers, and margins. DocX and Doc are used for Microsoft Word documents. XLSX and XLS are file formats for Microsoft Excel, a spreadsheet application. PDF format is primarily used by Adobe Acrobat and Adobe Reader. This format preserves document formatting so that no matter what device you open the file in, the file will look the same. And PPTX and PPT format are used for creating PowerPoint slides and decks for presentations. In this video, you learned that common file formats are executables, compressed, audio and video, image, and document. File formats are classified by name and extensions. Executable files run programs and applications. Some examples of executable files are exe, cmd, sh, bat, and msi. Compression files save disk space and are commonly used for archiving files or bundling large files. Common compression file types are zip, gzip, ISO, and jar. Audio and video files are media files. Some examples of audio and media files are WAV, MPEG, MP3, MP4, AVI, and WMV. Pictures, photos, and digital drawings can be stored as image files. Examples of common image files are BMP, GIF, JPEG, and PNG. And finally, document files are mostly text-based files, like DocX, PPTX, PDF, and RTF. Welcome to Common Web Browsers. After watching this video, you will be able to identify common web browsers and identify the components of a web browser. A web browser is the software interface that accesses resources on the internet, including text, images, music, video, and online games. As an internet user, you use a browser to request access to web pages on various websites. And it's the browser's job to request and retrieve that web-based content stored on a web server and display that content on web pages in the browser window on your device. You can use a web browser on several different types of devices, including desktop PCs, laptops, notebooks, tablets, smartphones, game consoles, and even smaller wearable tech devices such as smartwatches. It is estimated that in 2021, just over 5 billion people around the world used some type of web browser. According to statistical information provided by StatCounter Global Stats, as of October 2021, the most commonly used web browsers, according to worldwide market share across all platforms, are Chrome by Google, which has approximately 65% of the market share, Safari by Apple, which has around 19% market share, Edge by Microsoft, which has just under 4% market share, which is closely followed by Firefox by Mozilla, which has an approximate market share of just over 3.6%, the Samsung Internet Browser, which has just under a 3% share, and finally, the Opera browser, which has just over 2.3% share of the web browser market. Apart from the 6 most popular web browsers, there are several other alternative browsers that you could use instead. This table summarizes which browsers each operating system supports. Note that most web browsers can be used on any platform, but there are cases where the browser can only be used on a restricted set of operating system platforms, such as Apple's Safari browser, which can only be used on the macOS and iOS operating systems. And similarly, the Samsung Internet browser can only be used on Samsung Galaxy devices running Android 5.0 or later. A typical web browser is made up of various components. The user interface is where the user uses common UI elements, such as a search bar and an address bar, to enter a uniform resource locator or URL to search for content on the web. It includes navigation tools such as home, back, forward, and refresh buttons, along with other features such as history, bookmarks, and favorites to visit previously viewed pages or save links to web pages for later reference. The browser engine is the piece of code that is responsible for querying and controlling the rendering engine in the layer below it based on user interactions coming from the user interface layer above it, such as requests to load the URL and back and forward navigation when browsing. The rendering engine is responsible for presenting or rendering the requested web pages and content on your browser screen. Primarily, it interprets the hypertext markup language, or HTML code, XML documents, and images, and presents them in an easily digestible format on your browser screen. The rendering engine can also display other kinds of data by virtue of plugins or extensions. The networking component retrieves the entered URLs by using Internet Communication Protocols, namely Hypertext Transfer Protocol, or HTTP, and File Transfer Protocol, or FTP. This component is also responsible for handling a cache of recently retrieved content, which it can reissue when requested. This reduces network traffic by eliminating the need to constantly retrieve files from a web source that have been previously retrieved and have not changed since the last retrieval instance. The JavaScript interpreter, as the name suggests, interprets and executes any JavaScript code embedded in viewed websites. The interpreted results are directed to the rendering engine to be rendered on your browser screen. The user interface, or UI backend, is responsible for drawing basic widgets, such as windows and combo boxes, by using underlying operating system UI methods to expose a generic interface that is not platform-specific or dependent. And lastly, there is the data persistence or data storage component, which is essentially a small database located on the local device that stores user data such as cache, session storage, cookies, bookmarks, and user profile preferences. These components work together to give a web browser its core functionality. In this video, you learned that a web browser is the software interface to access resources on the internet, including text, images, music, video, and online games. You can use a web browser from desktop PCs, laptops, tablets, smartphones, game consoles, and wearable tech devices, such as smartwatches. The 6 most widely used web browsers are Chrome, Safari, Edge, Firefox, Samsung Internet, and Opera. Most web browsers can be used on any platform, but some can only be used on a restricted set of operating system platforms. And finally, web browsers consist of several integrated software components. Welcome to Browser Installs and Updates. After watching this video, you will be able to identify how to obtain web browsers and understand the need for web browser updates. So, how do you obtain a web browser? Well, there are really 2 options. It will either be provided as a part of an operating system, as is the case with Microsoft Edge on the Windows operating system, Safari on Apple devices, and Samsung Internet on Android devices. Alternatively, and in addition, you can download a web browser from a vendor's website or app store, but of course, for that you will first need a web browser to initially browse to the site or store. There is a huge amount of debate about which browser is better than the other, which is more secure than the other, which performs faster than the other, and so on. But as these web browsers are all free to obtain and use, you are also free to make your own decision about which one or more best suits your needs. So, there is absolutely nothing wrong or uncommon with having several different web browsers installed and running on your device. In any case, you will likely be asked by the operating system at some point to define your default browser. And this is the one the operating system will automatically use when you click a link in an app or an email, for example. You are probably already aware that it is important to keep your operating system and software applications up to date. Well, the same is true for your web browsers too. Here are some key reasons for keeping your web browsers updated. Compatibility with websites. As new web-based technologies emerge, websites start to use them, and therefore web browsers need to be improved and updated to support those new technologies. Any older versions of browsers that have not been updated may not be able to display or use some areas or features of a website. Security. If you don't keep your web browser updated to its latest version, it can lead to security vulnerabilities that expose your browser to the possibility of being compromised by some form of malicious software attack, such as a virus, keylogger, or spyware. These attacks can lead to the leakage of personal and/or financial information. New features. As developers add new or improved features to their browser software, or just generally improve its performance, your web browsers need to be updated to gain the benefits those improvements provide. Most of the top desktop web browsers provide standard fast release updates at the same release rate, which typically releases major updates every 4 weeks, but releases minor updates such as security fixes, crash fixes, and updates to policies on an as-needed basis within the 4-week period. This is currently the case for Google Chrome, Microsoft Edge, and Mozilla Firefox browsers. Aside from this standard fast release update frequency, some vendors also offer an extended release for updates, which provides updates at a much reduced frequency to help more structured environments such as large corporations, educational establishments, and government departments maintain browser stability over a longer period. Regardless of which flavors of web browser you use, updating them is relatively quick and simple. Most browsers have an automatic updates option that is often the default setting, which typically checks for updates every hour or so and on every browser restart. However, if needed, you can manually initiate a browser update too. For example, in Google Chrome, you select the Customize and Control Google Chrome icon in the top right corner of the browser window, point to Help, and then select About Google Chrome. Chrome will check for any available updates and download and install them. In Mozilla Firefox, click the Open Application menu icon in the top right corner of the browser window, then click Help, and then click About Firefox to check for updates. Firefox will check for any available updates, and you restart the browser to install the updates. In Microsoft Edge, click the Settings and More icon in the top right corner of the browser window, then point to Help and Feedback, and then click About Microsoft Edge. Edge will check for any available updates and download and install them. Once the update has been downloaded, you will need to restart Edge in order to complete the update process. Devices that run macOS regularly and automatically check for updates to the Safari browser and any other software installed via the App Store, and will prompt you to install updates as and when they are discovered using on-screen notifications. In the App Store, you can either update Safari alongside other applications as part of a single mass update process, or you can check for Safari updates only. If you want to manually check for and install updates to Safari only, select the Apple logo icon in the top left corner of the window, point to App Store, and then select the Updates tab. On the Updates tab, next to Software Update, select the More link. This will expand the System Applications list and enable you to select Safari from the list of applications. Next to the Safari version number, select Update, and the latest available version of Safari will then download and install. In this video, you learned that web browsers can be obtained as part of an operating system or via a download. The key reasons for keeping your web browsers updated are website compatibility, security, and new features. The top desktop web browsers provide major updates every 4 weeks and minor updates on an as-needed basis within the 4 weeks. And web browsers usually update automatically, but you can also update them manually if required. Welcome to Browser Plugins and Extensions. After watching this video, you will be able to define browser plugins, define browser extensions, and install and configure browser plugins and extensions. A web browser typically allows users to not only view HTML content, but also some other web-based content such as images, video, audio, and XML files. However, in most cases, to view other, more advanced types of content, you need additional software. A browser plugin, also sometimes referred to as an add-in or add-on, is essentially a small piece of software that provides some specific bit of additional functionality to a web browser. In this way, you can use plugins to customize your browser, and therefore your browser experience. So, a plugin extends the capabilities of your web browser. Common examples of a plugin are the Adobe Reader plugin that enables you to view PDF content, the Adobe Flash Player that lets you view FLV formatted videos, or the Java plugin that allows you to run applications written in the Java programming language. Typically, when you browse to a website that has this type of content available and you do not already have the appropriate plugin installed, you will be prompted with a link to download it. It is also worth noting that as plugins are improved to support new features or are updated to increase security, you will need to update your installed plugins too. Many web browsers now update their plugins automatically, but some older browsers may not. A browser extension is an application that provides extended functionality for a web browser and allows users to customize their web browsers. Extensions and plugins may seem similar, and although they do provide seemingly similar benefits to a web browser, they actually work quite differently. A browser plugin is an executable piece of software code that gives you added functionality on a specific web page or website, whereas browser extensions typically consist of source code that is not executable, but they extend the core functionality and features of the web browser itself, hence the term extension. So, a browser extension can customize a web browser's context menus, add buttons and toolbars, manage cookies, and block pop-up ads, for example, but a browser plugin cannot. Browser extensions are widely used, but in the last few years, browser plugins have largely been deprecated by most popular web browsers, and they no longer support them. As mentioned previously, some modern browsers do not support plugins at all. So, in Google Chrome, for example, there is no longer a plugins page available to view or the option to disable installed plugins. In browsers that still provide some support for standard plugins, such as Mozilla Firefox, you can configure the plugin settings. In Firefox, you open the application menu, select add-ons and themes, and select plugins in the left menu, which then displays the installed plugins. Select the ellipsis button next to the name of the plugin and select Manage. Here, you can configure the individual plugins settings, such as allowing automatic updates. You can also configure general plugin settings in Firefox by selecting the Tools for All Add-ons button. Here you can check for updates, view recent updates, install add-ons from a file, and configure the automatic updates setting. To configure browser plugins in Internet Explorer, you open the Tools menu, then select Manage Add-ons. Select Toolbars and Extensions in the left menu, which then displays the installed plugins and extensions. By default, it shows all currently loaded add-ons, but you can change this to display all add-ons instead. Then you can configure an individual plugin, such as enabling or disabling it. The method for installing browser extensions varies slightly between different web browsers. For example, to install web browser extensions in Microsoft Edge, you select the Extensions button on the toolbar, select Open Microsoft Edge add-ons, search for the extension you want to install, select Get, and then select Add Extension. Your new extensions toolbar will now be visible in your web browser. Whereas, to install browser extensions in Google Chrome, you browse to the Chrome Web Store, then, in the Extensions section, you search for the extension you want to install. Select the extension from the suggested list, select Add to Chrome, and then select Add Extension. And your new extensions toolbar will now be visible in your web browser. To configure browser extensions in Microsoft Edge, select the Extensions button on the toolbar, select Manage Extensions, and then either select Details to configure the extension, or select Remove to delete the extension from the web browser. To configure browser extensions in Google Chrome, select the Customize and Control Google Chrome button, point to More Tools, and then select Extensions. Here you can either configure the extension by clicking Details, remove it, or simply turn the extension on or off using the toggle switch. You may have noticed that some browser settings only allow you to disable a plugin or extension, but they do not allow you to remove them. In these cases, you need to use the Uninstall feature on your computer. For example, in Windows 10, from the Start menu, you select the gear icon to open Settings, select Apps, and then select Apps and Features. From this list of apps and features, you select the plugin or extension you wish to remove and select Uninstall, then follow the instructions. You may also find that malicious plugins and extensions will typically not appear in the list of installed apps and features on your operating system, and they will require more work to remove. The simplest way to do this is to run some form of trusted anti-malware program, which will help you to remove the offending item. Genuine plugins and extensions developed by reputable organizations can be very useful additions to your web browser and are safe to download and use. So, to avoid malware, ensure you trust the source of a plugin or extension before you install it. In this video, you learned that a browser plugin is a small piece of software that provides some specific bit of additional functionality to a web browser. You need to update your installed plugins. Most modern web browsers update plugins automatically. Plugins are largely deprecated by the major web browsers. Extensions enable users to customize a web browser. Extensions can customize a browser's context menus, add buttons and toolbars, manage cookies, and block pop-ups. Extensions are widely used by all web browsers. And you should ensure you trust the plugin or extension source before installing it. Welcome to Basic Browser Security Settings. After watching this video, you will be able to identify and access basic browser security settings, manage proxy server settings, and manage cookie and cache settings. The method for accessing security settings in each web browser is slightly different, but most of them offer similar kinds of settings to enforce security and privacy. For example, in the Google Chrome web browser, to access these settings, you select the Customize and Control Google Chrome button, that's the vertical 3 dots in the top right corner, and select Settings. Then you select Privacy and Security from the left navigation menu, and from here you can configure several settings, including clearing browsing data, configuring cookies and site data, configuring safe browsing options and managing certificates, and site permissions. You can also navigate directly to this settings page by browsing to Chrome://settings/privacy in the address bar. And in Microsoft's Edge web browser, you can access security and privacy settings by selecting the Settings and More button, that's the horizontal 3 dots in the top right corner, and select Settings. Then, for most security settings, you select Privacy, Search, and Services from the left navigation menu. Here, you can configure several security settings, including tracking prevention, clearing browser data, privacy settings, managing certificates, blocking unwanted apps, secure browsing options, and services settings. You can also navigate directly to this settings page by browsing to edge://settings/privacy in the address bar. In the left navigation menu, there is also a Cookies and Site Permissions option. Here you can manage and delete cookies and site data, as well as view and configure all your site permissions. You can also navigate directly to this settings page by browsing to edge://settings/content in the address bar. Other security settings you need to consider are the proxy server settings. A proxy server acts as a go-between when you browse the web, so that to the websites you are browsing, the site visitor appears to be the proxy server rather than your computer. There are several advantages to using a proxy server. Firstly, it can help protect your privacy when browsing the internet or bypass certain content restrictions. It can also help organizations and educational establishments to maintain web security, web monitoring, and content filtering when their employees are browsing the internet. This helps organizations control what web content is being accessed, when it is being accessed, and by whom, typically to comply with organizational security policies. Using a proxy server can also help reduce an organization's bandwidth usage and improve the speed of web requests. Proxy servers essentially work by modifying the IP address information in a web request to web servers to make the request appear to be coming from the proxy server rather than from the original requesting client computer on the proxy server's network. So the proxy server makes the request on the client computer's behalf. The response from the web server is sent back to the proxy server, and the proxy server then forwards the information onto the original requesting client computer. While retrieving the information on behalf of the requesting client PC, the proxy server will typically change the source IP address data and may also perform other tasks such as encrypting data and blocking access to certain categories of web content. To configure proxy server settings in Google Chrome, Microsoft Edge, and the Opera browser, you use the proxy settings defined by the operating system. For example, in Google Chrome and the Opera browser, you open Settings, then in the left navigation menu, expand Advanced, and select System. From here, you can select Open your computer's proxy settings. Similarly, in Microsoft Edge, you open Settings, then in the left navigation menu, select System and Performance, and again, you select Open your computer's proxy settings. In all cases in Windows 10, this action opens the proxy settings page. From here, you can either configure auto-detect proxy settings, or you can manually specify the proxy server address and port to use. Some other web browsers allow you to configure proxy settings that differ from those defined and controlled by the operating system. For example, in Mozilla Firefox web browser, you open Settings, then scroll down to Network Settings and select Settings. From here, you can either choose to use the operating system settings, which is the default, or you can choose Auto Detect or manually configured proxy server settings. Other devices, such as tablets and mobile phones, also allow you to configure proxy settings. For example, on an iOS device, such as an Apple iPhone or iPad, you open Settings, then navigate to Wi-Fi and select the name of your wireless network. Then scroll down to the HTTP proxy section and select Configure Proxy. And just like for other web browsers, you can choose between Off, Manual, and Automatic for your proxy server settings. Cookies are small pieces of text-based data that contain information about your computer when browsing a website. This information can be used to save session information for when a user revisits a website and to provide a more customized and targeted experience for the user. A classic example of a session-based cookie would be one that retains data about items in an online shopping basket when you are purchasing goods on a website. While most cookies can be useful, you should also be aware of the risks they bring, such as invading your privacy by tracking your browsing activities and targeting you with unsolicited online ads, and potentially more seriously, using cookie fraud to falsify your identity on the internet or use your legitimate identity to carry out malicious activities. Cookies can be viewed and managed in your web browser settings. In Google Chrome, you navigate to Settings, Privacy and Security, and then select Cookies and other site data. Many websites require cookies to be enabled on your browser in order to provide their online services, but there may be occasions when you wish to disable cookies, or at least be able to control whether they are created when you visit a website. You can allow all cookies, block third-party cookies, or block all cookies. Additionally, you may want to delete cookies when you no longer need them. You can also view the cookies currently saved by your browser. In the list of cookies, you can use the icons to either view the details about a cookie or delete it. Cache is the temporary area used by your web browser to store web data that can be quickly reused when requested, instead of needing to go back to the original source content. So, in this situation, if the web content hasn't changed since it was last retrieved, it can be served from the local disk rather than from the internet, and in this way, the cache can vastly improve the web browser's speed and performance and can help reduce bandwidth usage. If you want to ensure you are retrieving the latest content from the internet or are concerned about storing some data locally, you can clear or purge the cache from the disk. To manage cache in Google Chrome, navigate to Settings, Privacy and Security, then select Clear Browsing Data. In the Clear Browsing Data dialog box, you need to select the time range, which can be from 1 hour up to all time. Then select the Cached Images and Files checkbox and select Clear Data. In this video, you learned that a proxy server acts as a go-between when web browsing. Proxy servers help organizations reduce bandwidth usage, improve speed of web requests, and maintain security. You can configure either manual or automatic proxy server settings. Cookies are the small text-based files containing information about your computer when browsing. Cookie settings can be configured to allow all cookies, block third-party cookies, or block all cookies. Cache is a temporary storage area, so data can be quickly reused when requested. And you can clear the cache from the disk when it's no longer required. Welcome to Browser Security Certificates and Pop-up Settings. After watching this video, you will be able to identify and access advanced browser security settings, verify security certificates for websites, and configure pop-up settings. The method for accessing security settings in each web browser is slightly different, but most of them offer similar kinds of settings to enforce security and privacy. For example, in the Google Chrome web browser, to access these settings, you select the Customize and Control Google Chrome button. That's the vertical 3 dots in the top right corner, and select Settings. Then you can select Privacy and Security from the left navigation menu, and from here you can configure several settings, including configuring safe browsing options, managing certificates, and configuring site settings such as site permissions and pop-ups. You can also navigate directly to this settings page by browsing to Chrome://settings/privacy in the address bar. And in Microsoft's Edge web browser, you can access security and privacy settings by selecting the Settings and More button, that's the horizontal 3 dots in the top right corner, and selecting Settings. Then, for most security settings, you select Privacy, Search, and Services from the left navigation menu. Here, you can configure several security settings, including tracking prevention, managing certificates, blocking unwanted apps, and secure browsing options. And again, you can also navigate directly to this settings page by browsing to Edge://settings/privacy in the address bar. When you are browsing websites, especially those that you have never visited before, and even more crucially, if you are using the website of a financial institution, such as an online bank, it is a good security practice to check the authenticity of those websites. You can identify a secure website by looking for the padlock icon next to the URL in the browser's address bar. And when you click the padlock, you should see the message, "Connection is secure." If you don't see the padlock icon and instead see a warning icon and the words "not secure" to the left of the URL, then this site is not using the Secure Sockets Layer or SSL protocol. So, in other words, you are accessing it by using the HTTP protocol rather than the more secure HTTPS protocol. SSL, or more accurately, SSL over TLS, or Transport Layer Security, is a protocol standard for secure communications between two systems over the Internet by virtue of encryption algorithms. When you see the not secure message to the left of the URL, it means that either the SSL security certificate on the website you are visiting has expired and therefore needs renewing by the hosting website, or the security certificate has been signed or authorized by an issuing authority that is not trusted by the browser. In other words, the certification authority, or CA, is not on the browser's built-in list of trusted certificate providers. If you click the Not Secure message, you will see a dialog box that informs you that the connection to the website is not secure, and the message also warns you about entering sensitive information on this site. Even when you are browsing a website that is displaying the padlock icon, if you are unsure about its authenticity or just want to dig a bit deeper into the security information behind that website, you can view the security certificate that has been issued to the web server hosting the website. The certificate is issued by a certification authority, or CA. To view a website security certificate in Google Chrome, browse to a website using the HTTPS protocol and click the URL address in the address bar to display the full URL. Select the padlock icon to the left of the URL and select Connection is secure. Then select Certificate is valid, and the web server certificate will open in a separate dialog box. Here you can view general certificate information, such as the issuing CA and the validity dates. On the other tabs, you can view detailed information about the certificate, such as its serial number, security algorithms, and its certification path back to the issuing CA. Many websites contain pages that host third-party scripts or pop-up ads, also known simply as pop-ups, which are typically used to target you for online marketing purposes. They can sometimes be a little annoying as they might distract you from your intended purpose and can literally get in the way of what you are trying to view on a website. But while they may be simply annoying, there is also the potential for them to be malicious as well, and the developers of these pop-ups will usually associate them with some form of on-screen activity, such as clicking a button. The button could be labeled Close or Cancel, and therefore may appear to be totally legitimate. Another common type of malicious pop-up is ransomware that looks like a notification from a government agency, such as the IRS or the FBI. Ransomware is malware that can enable hackers to take control of a victim's computer if they click a link in the pop-up notification. So, to maintain security and for a better browsing experience, you should be very careful when interacting with these kinds of items. It is also important for you to know how to block these items when browsing a website. Most modern web browsers include built-in tools for blocking pop-ups, but there are many third-party pop-up blockers or ad blockers available on the market, such as AdBlock, AdGuard, AdBlock, Ghostery, and AdBlock Plus. And some of these include additional features, such as ad filtering. Today's modern web browsers block pop-ups by default. This is typically indicated in your web browser by an icon in the browser's address bar or a notification dialog box. To modify Google Chrome's behavior when encountering pop-ups, open Settings and select Privacy and Security. Select Site Settings and then scroll down to the Content section and select Pop-ups and Redirects. Here you can choose which default behavior to use for pop-ups. The options are either to allow all sites to send pop-ups and use redirects, or to not allow any sites to send pop-ups and use redirects. However, you can also customize this default behavior by adding sites to the allowed list and/or the blocked list. For example, here we have added the popuptest.com and amazon.co.uk sites to the blocked list, and the skillup.tech and bbc.co.uk sites to the allowed list. Note that you can use the syntax square bracket asterisk dot square bracket before the domain name, which will then include all subdomains as well. In this video, you learned that it is a good security practice to check the authenticity of websites you are visiting. You can identify a secure website by looking for the padlock icon next to the URL in a browser's address bar. Pop-ups are typically used to target you for online marketing purposes. And while pop-ups are annoying and distracting, they can also be malicious. Modern web browsers include built-in pop-up blocking tools, but you can also use third-party pop-up blocking apps. And you can modify your browser's default behavior when encountering pop-ups. Welcome to Private Browsing and Client-Side Scripting Settings. After watching this video, you will be able to enable private browsing mode in web browsers and manage client-side scripting settings. If you want to hide your browsing activity, then you can utilize private browsing, which is a web browsing mode that does not save the kinds of information about your activity that a standard browsing session would, such as the history of visited websites, passwords entered, data entered in web forms, cookies, and session cache. This data is deleted when you close the private browsing window. But please note that this only hides the information locally from people who might use the web browser on the device after you. It does not hide the information from your Internet Service Provider or ISP, or from the websites and web servers that you visit. Additionally, your place of education or your workplace might also be able to view this data. All the major web browsers have a private browsing mode, but they refer to it by different names. For example, in Google Chrome, it is called Incognito Mode. In Microsoft Edge, it is referred to as In Private. And in Firefox and Opera browsers, it is simply called Private Browsing. In Google Chrome, you can start a private browsing session by selecting the Customize and Control Google Chrome button in the top right corner, then selecting New Incognito window. In Microsoft Edge, you select the Settings and More button in the top right corner, then select New in Private window. And in Opera, you select the Customize and Control Opera logo in the top left corner, then select New Private window. Alternatively, in all three of these cases, you can use the shortcut key, which is Ctrl+Shift+N. But in the Mozilla Firefox browser, the shortcut is Ctrl+Shift+P. In the early days of the World Wide Web, most web pages were written in HTML, and they were fairly static pages. That is, the page looked the same to every user who visited it. This issue was resolved by the development of dynamic web pages that could adapt to the needs of different scenarios and different viewers of the web page. These dynamic pages are generally generated in one of two ways. Either the processing is done by the server that is hosting the dynamic content. This is referred to as server-side scripting. Or the client computer is responsible for the processing, which is referred to as client-side scripting. With client-side scripting, special code is embedded in the web page itself, and the user's web browser does the required processing to retrieve the data. By far, the most common example of this kind of client-side scripting code is JavaScript. These client-side scripts will generally provide a set of instructions to be performed by the browser. The key benefits of client-side scripts are that users can see the scripts on the front end. They do not need to rely on server resources, and therefore they can help reduce the load on servers. However, although client-side scripting can be very useful, it also brings its own dangers in terms of security implications. In theory, the instructions contained in the code that is processed by the web browser could instruct the browser to perform all manner of malicious actions, including accessing settings and data on the local computer. Fortunately, web browsers are designed with inbuilt security measures to mitigate against most of these kinds of security threat, such as restricting the code to only executing within the browser and therefore not allowing access to the local computer system. However, malware developers are constantly trying to find new ways to circumvent these security measures or detect flaws in them. Therefore, it is important for you to be able to control client-side scripting in your web browser. To help you decide whether or not you should disable JavaScript in your web browser, here are some pros and cons of disabling it. First, some of the pros. The major pro for disabling JavaScript is security. One of the biggest known potential issues with JavaScript is suspicious web pages, and the possibility and opportunity for malicious code to be run in your browser that could adversely affect your computer. Browsing speed could be improved by eliminating the dynamic content that JavaScript can provide. Not all browsers are capable of supporting and running JavaScript effectively, as they can each interpret the code in a different manner, which could lead to inconsistencies in functionality and the overall browsing experience. If you disable the JavaScript programming language, you can make sure that your browser successfully views and loads pages correctly, particularly in the case of older web pages and websites. Another major issue for Internet users is that companies can track their Internet usage and then sell that data onto other interested companies. If you disable JavaScript, a lot of the cookies that are responsible for the gathering of this personal information will no longer function correctly. And now, some of the cons. When you disable JavaScript, you lose the ability to view a lot of the useful dynamic content that is available on the Internet, such as images, videos, maps, and various types of media. Additionally, many of the features that create the user interface will disappear, which can look very confusing and hard to read on a website that contains a lot of JavaScript-based content. With JavaScript disabled, it can be much harder and take much longer to search for and scroll through the content on dynamic web pages, and you may find yourself needing to continually click on next links to progress through the content. If you want to stop JavaScript scripts being run in your web browser, you can disable them in your web browser settings. For example, in Google Chrome, you select Settings, then Privacy and Security, then Site Settings, and then under the Content section, you select JavaScript. Here, you can set the default behavior to either allow all sites to run JavaScript or to not allow any sites to run JavaScript. The default for this setting is to allow all sites to run JavaScript. If you want to set a custom behavior for some sites, you can either block specific sites from running JavaScript scripts, or you can allow specific sites to run them. As before, you can use the syntax square bracket asterisk dot square bracket in front of the domain name to include all subdomains as well. When deciding whether to block these client-side JavaScript scripts or not, you need to balance between the additional functionality they provide on a website against the potential security risks they might pose. This is what you might see when you visit a website that you have added to the list of sites that are not allowed to run JavaScript code. You then have the option of continuing to block JavaScript on this site or allowing it. In this video, you learned that you can hide your browsing activity by using private browsing, which does not save historical information about your activity. Private browsing only hides the information locally from people using the web browser on the device after you. Dynamic web pages can adapt to different situations and different users. With client-side scripting, code is embedded in the web page and the user's web browser performs the required processing. And you can stop JavaScript scripts being run in your web browser or on specific sites. Welcome to Introduction to Cloud Computing and Cloud Deployment and Service Models. After watching this video, you will be able to describe cloud computing concepts, define cloud deployment models and cloud service models, and identify the characteristics of cloud computing. Cloud computing, also referred to as the cloud, is the delivery of on-demand computing resources such as networks, servers, storage, applications, services, and data centers over the Internet on a pay-for-use basis. The term cloud computing can be used to describe applications and data that users access over the Internet rather than on their local computer. Examples of cloud computing include users using online web apps, employees using secure online business applications to conduct their work, and users storing personal files on cloud-based storage platforms such as Google Drive, OneDrive, and Dropbox. One of the main user benefits of cloud computing is that instead of users needing to purchase their own applications and install them locally on their computer, they can use online versions of those applications and pay a monthly subscription. Not only is this typically more cost-effective initially, but users can also access the latest version of the application without having to purchase a full retail copy of the newer version. A side advantage of this is that the user also saves lots of local storage space as the application is hosted online. And the beauty of most cloud-based applications is that they also enable users to work collaboratively with their colleagues working on the same files in real time and being able to see each other's edits and updates. Cloud computing is composed of 5 essential characteristics, 3 deployment models, and 3 service models. Let's start with understanding the 5 essential characteristics of the cloud. On-demand self-service means that you get access to cloud resources such as the processing power, storage, and network you need using a simple interface without requiring human interaction with each service provider. Broad network access means that cloud computing resources can be accessed via the network through standard mechanisms and platforms such as mobile phones, tablets, laptops, and workstations. Resource pooling is what gives cloud providers economies of scale, which they pass on to their customers, making cloud cost-efficient. Using a multi-tenant model, computing resources are pooled to serve multiple consumers, and cloud resources are dynamically assigned and reassigned according to demand, without customers needing to know the physical location of these resources. Rapid elasticity implies that you can access more resources when you need them and scale back when you don't, because resources are elastically provisioned and released. And measured service means that you only pay for what you use or reserve as you go. If you're not using resources, you're not paying. Resource usage is monitored, measured, and reported transparently based on consumer utilization. As you have seen, cloud computing is really about using technology as a service, leveraging remote systems, on demand, over the open internet, scaling up and scaling back, and paying for what you use. And it has changed the way the world consumes compute services by making them more cost-efficient, while also making organizations more agile in response to changes in their markets. Cloud deployment models indicate where the infrastructure resides, who owns and manages it, and how cloud resources and services are made available to users. There are 3 types of cloud deployment models: public, private, and hybrid. Public cloud is when you leverage cloud services over the open internet on hardware owned by the cloud provider, but its usage is shared by other companies. Private cloud means that the cloud infrastructure is provisioned for exclusive use by a single organization. It could run on premises, or it could be owned, managed, and operated by a service provider. And when you use a mix of both public and private clouds working together seamlessly, that is classified as the hybrid cloud model. Now, let's look at the 3 cloud service models that are based on the 3 layers in a computing stack: infrastructure, platform, and application. These cloud computing models are aptly referred to as Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS. In an IaaS model, you can access the infrastructure and physical computing resources, such as servers, networking, storage, and data center space, without the need to manage or operate them. In a PaaS model, you can access the platform that comprises the hardware and software tools that are usually needed to develop and deploy applications to users over the internet. And an SaaS is a software licensing and delivery model in which software and applications are centrally hosted and licensed on a subscription basis. It is sometimes referred to as on-demand software. In this video, you learned that cloud computing is the delivery of on-demand computing resources over the internet on a pay-for-use basis. Cloud computing is composed of 5 essential characteristics, 3 deployment models, and 3 service models. The 5 essential characteristics of cloud computing are on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. There are 3 types of cloud deployment models: public, private, and hybrid. And the 3 cloud service models are based on the 3 layers in a computing stack: infrastructure, platform, and application, and they are referred to as Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS. Welcome to Application Architecture and Delivery Methods. After watching this video, you will be able to define application architecture models and define application delivery methods. When developers create an application, they must ask, how will an application be used and how will it be accessed? Also, will the application be 1-tier, 2-tier, 3-tier, or N-tier? Depending on the size of the application, developers need to determine the application architecture that will work best. The 1-tier architecture is a single-tier model. It is also sometimes referred to as the monolithic model. All the components of an application run on one local computer. The 2-tier architecture model consists of 2 sides: a workspace-based client, like your personal computer, and a web server or a database server. It's a 2-tier model because the application is kept in 2 places: the hardware of the user and the hardware of the server. The 3-tier architecture divides applications into 3 tiers: the workspace-based client, the application server or web server, and another server like a database server. The benefit of a 3-tier architecture is that each tier can be individually developed and updated by a separate team, and each tier can be modified and upgraded without affecting the other tiers. The N-tier model has a number of tiers. The N in N-tier stands for number. Sometimes it is referred to as a multi-tier model. It has a workspace-based client tier, like a personal computer. It could also have a web server or a database server tier. It might have a security tier. And it has several other tiers with additional servers. And the N-tier model is more popular than the 1-tier monolithic pattern because it is more in line with the microservices pattern and the Agile model. There are some advantages and disadvantages of N-tier applications. Some of those are: code changes and updates can be made to specific tiers, which takes less time than changing all tiers. Each tier can have its own security settings. Different tiers can be load balanced, distributing application activity in the least busy server in a group of servers where the application is hosted. Tiers can be individually backed up by IT administrators. And changes, updates, and backups may take longer because there are more tiers. There are several different ways that applications can be available to users: local installation, hosted on a local network, and cloud hosted. A user can locally install an application, such as a game, on their computer. The application exists on their local computer and a network connection is not required. Files for the application are saved locally on the user's personal device. Some applications are local network hosted. Applications are used over a hosted network, such as over a local area network or LAN, or a wide area network, WAN. Users can access the applications on the server's local storage. An internet access is not required, however, a network like a LAN or WAN is required. Cloud-hosted applications are available over the internet. To use the application, internet access is required and normally paid access or a subscription to the service that provides the application is required. And files are saved in the cloud, so they do not need to be saved locally to your computer or device. In this video, you learned that application architecture models are made up of 1-tier, 2-tier, 3-tier, and N-tier models. The benefits of a three-tier architecture are that each tier can be individually developed and updated by a separate team, and it can also be modified and upgraded without affecting the other tiers. N-tier models are currently the most used because changes can be made quickly to individual tiers. Each tier can have its own security settings. Tiers can be load balanced, and each tier can be individually backed up. And finally, application delivery methods are local installation, hosted on a local network, and cloud-hosted. Welcome to Software Development Lifecycle. After watching this video, you will be able to describe the Software Development Lifecycle or SDLC framework, explain the different phases of the SDLC, and identify the various SDLC models. The SDLC is a structured framework that defines the steps in creating and developing software. Organizations follow a detailed plan to develop, maintain, or enhance specific software. The SDLC framework details a methodology for consistent software development that ensures quality software production. There are 6 major steps in the SDLC process: requirement analysis and planning, design, coding, testing, deployment, and maintenance. In the first stage of the SDLC, the requirement analysis and planning phase, all relevant information is gathered from the customer. As part of the planning process, labor and material costs are calculated, targets are estimated, and project teams and leaders are proposed. Feedback is also gathered from stakeholders on the requirement analysis document. When planning a software solution, several factors must be considered: users of the solution, overall purpose of the solution, data inputs and outputs, legal and regulatory compliance, risk identification, quality assurance requirements, allocation of human and financial resources, and project scheduling. These specifications are combined into a document called a Software Requirement Specification, or SRS document. The SRS document needs to be clearly understood and approved by the stakeholders. The developers are also involved at this stage for a clear understanding of the requirements. In the design phase, the requirements gathered in the SRS document are used as an input, and a software architecture is developed and reviewed by the stakeholders and team. The document created in this phase is called a design document, and it is used by developers for the coding process. The coding or implementation phase is when the developers start the coding process once the design document is baselined. The project planners assign code development tasks to the developers, and teams in turn start coding. A modular or microservices approach is often used, and code chunks are created as outlined in the design document. This is one of the longest phases of the SDLC process. The testing phase is next in the process once coding is complete. Some large projects have dedicated testing teams. Created code needs to be thoroughly tested to ensure it is stable, secure, and performs the necessary functions. Testing can be manual, automated, or a hybrid of both. Product bugs are reported, tracked, and fixed, and code is retested until the software is stable. Some common testing types are unit testing, regression testing, integration testing, and stress testing. The deployment phase is where the application is released into the production environment and made available to users. This can also happen in stages. First, it is released onto a user acceptance testing or UAT platform, and once the customer signs off on the functionality, it is released to production. This approach can be used for making software available on a website, mobile device app store, or a software distribution server on a corporate network. The maintenance phase, once the code has been deployed into the production environment, is required to fix any issues as they come up, or to enhance the code as needed. If bugs are discovered in this phase that were missed during testing, then these errors are fixed or planned as part of a future software release. At each phase of the SDLC cycle, documentation is maintained and metrics are recorded and evaluated for compliance. There are various models that implement the SDLC methodology. Some of the popular ones are waterfall, iterative, spiral, V-shaped, agile, and lean. A waterfall model is also called a linear sequential model. The output of one phase is the input for the next phase in the cycle. Development and work on the next phase start only after the completion of the previous phase. The iterative model is also called an iterative incremental model. Product features are developed iteratively, and once all iterations are complete, the final product build includes all the features of the product. The spiral model uses both the waterfall and prototype models. It is best suited for large projects, and it reduces risk to a large extent. The spiral model has 4 phases: planning, risk analysis, engineering, and evaluation. The spiral model phases are followed iteratively. The V-shaped model is also called a verification and validation model. Development and testing are concurrent, that is, testing is implemented parallel to the development phase. The Agile model focuses on a collaborative software development process over multiple short cycles rather than a top-down process. Teams work in cycles or sprints, which are 2 to 4 weeks long. Testing happens in each sprint to minimize the risk of failure. Agile is a form of an iterative approach to development. At the end of each iteration, a minimum viable product is developed that can receive user feedback, and this process is repeated for every sprint cycle. The 4 core values to Agile development are individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. The Lean model is the application of Lean principles to software development. Like Agile development, the Lean model also focuses on delivery speed, continuous improvement, and reducing waste in every phase. The Lean methodology is based on 7 principles: eliminate waste, build in quality, create knowledge, defer commitment, deliver fast, respect people, and optimize the whole. DevOps methodology evolved from application of Agile and Lean practices to operations work, wherein development and operations teams work collaboratively to accelerate the deployment of software products. There are some differences between a traditional SDLC and the Agile method of software development. Traditional SDLC centers around the whole product being developed before being sent to the customer, and the Agile focuses on short, quick bursts of development. Research and planning are often completed at the beginning of a project in a traditional SDLC. The Agile development is different, relying on ongoing research, planning, and testing during product development. When adding new features into a project, development must go through the same waterfall process of a traditional SDLC, but in Agile, new features are handled quickly and easily. In this video, you learned that the SDLC is a framework for software development in a systematic manner. The SDLC phases are broadly classified into 6 steps: requirement analysis and planning, design, coding, testing, deployment, and maintenance. And there are several SDLC models. The most popular ones include waterfall, iterative, spiral, and agile. Welcome to Interpreted and Compiled Programming Languages. After watching this video, you will be able to identify interpreted programming languages and identify compiled programming languages. What are programming languages? Programming languages help us tell computers what to do. Computers don't use human language, they use their own language called machine code. Machines understand binary code, that is, ones and zeros, so to make communicating with computers easier, we have human-readable programming languages. 2 common categories for programming languages are interpreted and compiled. These are broad categories, and there are many programming languages that are classified under compiled languages and interpreted languages. The purpose of the project helps a developer determine which programming language is best. Interpreted language is also commonly referred to as scripted or scripting language. Programs written in interpreted or scripted language, like Python and HTML, run through the programming interpreter on your computer's operating system or in your web browser. Remember that programming languages are in human-readable code, so the interpreter takes the human-readable scripted code and then translates it into machine code, enabling the computer to complete the requested task. As computers and web pages have changed and advanced, some interpreted programming languages are outdated, and they are not as useful or relevant. Some other languages are more versatile and easier to learn, which means they are preferred over other scripting languages and are used more often. All interpreted programming languages need an interpreter to translate the source code. Translators are built into your web browser, or they require a program on your computer to translate the code. Several different interpreted programming languages exist. Some examples of common interpreted programming language types are JavaScript, a simpler scripting language that runs through the web browser interpreter. Python, a language that is popular because it is easy to learn and use for developers. Lua, a general-purpose, lightweight game scripting language that is easy to learn and use. And HTML, a markup language used for formatting web pages. Another category of programming languages is the compiled programming languages. Compiled programs are applications and programs, like your music app or your operating system, that you run on your computer or device. The programs are packaged or compiled into one executable file. They are usually larger programs. Compiled programs are used to help solve more challenging problems like interpreting source code. Compiled programming languages are often referred to more simply as programming languages. A compiler program creates a program file, which runs the software. Simply put, it piles the code into one file that runs when you double-click on the app on your device. The program runs faster, and it can be done repeatedly. The source code is converted from the programming language to machine code. Then it is compiled into one executable file. Finally, the program runs when you select the icon or file on your device. Some examples of compiled programming languages are C and its variations, C++ and C#, which are used in many operating systems like Microsoft Windows, Apple's Mac OS, and the open source operating system, Linux. Java is another compiled programming language. It shouldn't be confused with the interpreted language JavaScript. The Android OS is written in Java because it works well across computing platforms. Let's look at this process. When you update to a new version of your operating system, like Microsoft Windows, your device might download an installation program. That program is made up of many files. The files are written in a compiled programming language. These files give instructions to your device in machine code. The compiled program is running on your device. A compiled program that you commonly use is your device's operating system, such as Linux, Microsoft Windows, Apple's Mac OS, or Android. Your operating system is written in a compiled programming language, like C, C++, C#, or Java. In this video, you learned that interpreted programming languages run scripts that are repetitive and need to be run often. Interpreted programming languages are more versatile and can be used across platforms as long as there is the correct interpreter. Some examples of interpreted programming languages are JavaScript, Python, and HTML. Compiled programming languages are for more complex programs that complete larger tasks. Compiled programming languages are used for creating executable files that can run directly from your device. And some examples of compiled programming languages are C and Java. Welcome to Comparing Compiled and Interpreted Programming Languages. After watching this video, you will be able to compare interpreted and compiled programming languages and discuss interpreted and compiled programming languages. How do developers choose a programming language? Developers choose which programming language is best to use depending on what they have the most experience with and what they trust, what is best for their users, and what is the most efficient to use. What are interpreted and compiled programming languages? Interpreted programming languages are used to create a scripted source code for smaller tasks. The source code goes through an interpreter. The interpreter is built into the operating system on a computer or on a web browser. Compiled programming languages are used to create files. The files are executable files. They are then grouped in programs that you can run on a computer or device. Interpreted programming languages are also called script code or scripting because they are used to automate tasks. Interpreter programs read and execute the source code line by line like someone would read a script. Each time the program runs, the source code needs to be executed to receive the desired output. And source code written in one of the interpreted programming languages runs on almost any operating system with the right interpreter. For example, imagine you have a client requesting information about web page views for last month. Which type of programming language would be the most appropriate and efficient to create a program for this task? You would use one of the interpreted programming languages to write code for a script. The script would retrieve the web page views data and then put it into a table for the client to read. Compiled programming languages are also called programming languages for short. They are used for more complex programs that complete larger tasks like running a spreadsheet program on your computer. A compiled programming language is used to write a larger program, usually installed on your device as an executable file. Writing code in a compiled language does take longer, but the payoff is that the program's code runs faster because compiled programs are installed on the device. And once the program is coded, the compiled program is grouped into one downloadable file. Remember that client who wanted information about web page views? Now they want a spreadsheet program to view and manage the data. A programmer could use the C programming language to create a compiled program like Microsoft Excel. So, what are the major differences between interpreted programming languages and compiled programming languages? First, there's interpreted programming. These programs are available across multiple platforms or in the cloud. The scripting languages are easier to learn and use, and they're better for websites because they tackle smaller, repeated processes. Then there's compiled programming. These programs are available to users with the same operating system coded in the same language. However, compiled programming languages are more difficult to learn and use because they are larger programs with more parts. And they're better for larger tasks like running the operating system on your computer. To better understand more of the similarities and differences of programming languages, let's take a look at some examples. A few of the most common programming languages are C, C++, and C#. C is a compiled programming language. C is the original language, and C++ and C# are variations. C and its variations are case-sensitive languages. The C programming language is the basis for Windows and other common operating systems. And it takes more time to learn and use for coding, but requires less memory and the code runs faster. Another common programming language is Java. It is a compiled programming language. It is also a case-sensitive, object-oriented programming language. The Java Virtual Machine, or JVM, is required to run the code written in Java. It is the primary programming language for some operating systems, like the Android OS. And a benefit of Java is that it is a cross-platform language, which means it runs the same code on Mac OS, Windows, and Linux. Python is an example of an interpreted programming language. It is also referred to as a scripting language. Python is a popular general-use case-sensitive programming language. It is used with Windows, Mac OS, and Linux operating systems, and with server-side web app code. And it requires the Python engine to interpret code. JavaScript is another interpreted programming language. It is a scripting language that runs on the client side in web browsers. JavaScript is case-insensitive. Simple scripts are run with HTML. Complex scripts are run in separate files. And while it sounds similar, it shouldn't be confused with Java, the compiled programming language. Another example of a common programming language is HTML. It is an interpreted programming language. HTML stands for Hypertext Markup Language. HTML is mostly case-insensitive with some exceptions, and it uses tags to format web pages on client-side web browsers. In this video, you learned that interpreted programming languages create source code that runs through an interpreter in your device's operating system or on your web browser. Compiled programming languages create executable files that are grouped in programs on your device. Compiled programming languages, like C and Java, are used to write larger programs like operating systems and other executable files. And interpreted programming languages, like Python and HTML, are used to write code that can complete repetitive tasks within a web browser or a computer. Welcome to Query and Assembly Programming Languages. After watching this video, you will be able to compare high-level and low-level programming languages, describe query languages, and describe assembly languages. Let's explore query and assembly programming languages. But first, we need to categorize programming languages into two levels, high-level and low-level. A high-level programming language is more sophisticated and uses the common English language to make its code more understandable and to increase the speed of coding and debugging programs. Examples of high-level programming languages include query languages, such as Structured Query Language or SQL, structured programming languages, such as Pascal, and object-oriented programming languages, such as Python. In contrast, a low-level programming language uses a set of symbols to represent machine code. Examples of low-level programming languages include assembly languages such as ARM, MIPS, and x86. A query is a request for information from a database. The database handles the query and searches its tables for the information requested and returns the results to the querying entity. When querying a database, it is important that both the user application making the query and the database handling the query are speaking the same language. In programming terms, writing a query means using predefined and understandable instructions to make the request to a database. This is achieved using programmatic code, and this is what we refer to as a query language. A query language may also be referred to as a database query language. By far the most prevalent query language for database queries and database management is SQL. However, there are other query languages available, such as AQL, CQL, Datalog, and DMX. In addition to SQL databases, there is another type of database called NoSQL, which stands for Not Only SQL. The key difference between these two types of databases is their data structures. While SQL databases are relational and use structured, predefined schemas, NoSQL databases are non-relational in nature and have dynamic schemas for unstructured data. A query language is predominantly used to request data from a database or to create, read, update, and delete data in a database. You will likely see the term CRUD used to refer to these last four key database operations. Typically, a user enters a command to either make a query or perform a CRUD operation using syntax that is understandable to the database management system hosting the database. And a database typically consists of structured tables made up of multiple rows and columns of data. When a user performs a query, the database retrieves the data from the relevant rows and columns in the table and arranges it into some sort of order ready to be returned and presented in the query results. Database queries are either a select command or an action command such as create, insert, update, or a mixture of both. The term statement is more commonly used to describe these commands. Select queries request data from a database, whereas action queries manipulate data in a database. Query statements can also be used to perform other administrative functions, such as creating users and modifying permissions. This table lists some of the most common SQL query statements. And here are some simple syntax examples of common SQL statements. As mentioned earlier, assembly languages are less sophisticated than query languages, structured programming languages, and object-oriented programming languages. As an assembly language uses a simple set of symbols to represent the zeros and ones of machine code, it is categorized as a low-level programming language. Assembly languages are closely tied to the processor architecture from hardware manufacturers, and therefore each CPU type will typically have its own assembly language. For this reason, there are a large number of assembly languages in use today, which vary among hardware manufacturers. Assembly languages use a simple, readable format for their statements, and they are entered one line at a time with one statement per line. Assembly language statements use the standard format shown here. In this syntax, all fields in curly brackets are optional, and the statement has two main parts. The first part is the instruction, or the mnemonic, and the second part includes the parameters, or the operands. There may also be optional useful comments added on the end of the statement. One other key difference with assembly languages is that they are translated using an assembler instead of a compiler or interpreter, and one statement translates into just one machine code instruction, as opposed to high-level languages where one statement can be translated into multiple machine code instructions. Assemblers translate assembly language into machine code using mnemonics such as input INP, output OUT, load LDA, store STA, and add ADD. The statements consist of opcodes that tell the processor what to do with the data and operands that tell the processor where to find the data. In this video, you learned that query languages, structured programming languages, and object-oriented programming languages are categorized as high-level programming languages. Assembly languages are categorized as low-level programming languages. A query language is predominantly used to request data from a database or to manipulate data in a database. The most prevalent query language for database queries and database management is structured query language, or SQL. Select queries request data from a database, whereas action queries manipulate data in a database. You also learned that assembly languages use a simple set of symbols to represent the zeros and ones of machine code. Assembly languages are closely tied to the processor architecture from hardware manufacturers. Assembly languages are translated using an assembler instead of a compiler or interpreter. And assembly language instructions have a one-to-one association with their machine code counterpart. Welcome to Understanding Code Organization Methods. After watching this video, you will be able to explain why code organization methods are important when programming, define the different code organization methods, and identify the benefits of using code organization methods. Organizing is very important when it comes to reading, maintaining, and configuring code. Well-planned-out software design, usually using one of several methods, helps programmers write cleaner and more reliable code. Planning out code in a visual format helps improve the code base once it is written and reduces the chance of bugs and errors throughout the lifespan of a project. Organizing code before programming has a positive impact on the quality of the program and helps provide a consistent and logical format to use while coding. There are two main methods of organizing code: flowcharts and pseudocode. The main difference between pseudocode and a flowchart is that the former is a basic high-level description of an algorithm. An algorithm is a step-by-step sequence of solving a given problem. A flowchart is a pictorial representation of an algorithm, showing the steps as boxes of various shapes and colors connected by arrows that indicate their order. Flowcharts are used in designing or documenting a process or program. Pseudocode provides a beneficial bridge to the project code because it closely follows the logic that the code will. Pseudocode also helps programmers share ideas without spending too much time creating code, and it provides a structure that is not dependent on any one programming language. Flowcharts are especially beneficial for smaller concepts and problems, while pseudocode is more efficient for larger programming projects. And flowcharts provide an easy method of communication about the logic and offer a good starting point for the project because they are easier to create than pseudocode in the beginning stages. A flowchart is the graphical or pictorial representation of an algorithm using different symbols, shapes, and arrows in different sizes and colors to demonstrate a process or a program. The main purpose of using a flowchart is to analyze different methods of solving a problem or completing a process. Several standard symbols are applied in a flowchart, and you can easily highlight certain elements and the relationships between each part in the process. Some traditional flowchart shapes used for programming concepts are start-end, a capsule, process, a rectangle, decision, a diamond, data, a parallelogram, and connectors as arrows. A simple flowchart to represent how to add two numbers is easy to create. The procedure starts with the capsule and has a connector or arrow progressing to the next step, the data input, the parallelogram, in this case, input N1 and input N2. Then another connector or arrow goes to the process, the rectangle of adding the two inputs, sum equals N1 plus N2. Another connector or arrow moves to the data, the parallelogram, showing the result, in this case, print sum. And the last connector or arrow moves to the end of the process, the end capsule. Flowchart software is an application that provides various functionalities to create flowcharts by providing the ability to drag shapes into the desired order using an easy-to-use editor. Flowchart software also provides team collaboration for creating flowcharts. Some of the well-known flowchart software programs include Microsoft Visio, Lucidchart, Draw.io, and Draw Anywhere. Pseudocode is an informal type of programming description that does not require any strict programming language syntax or underlying technology considerations. System designers write pseudocode to ensure that programmers understand a software project's requirements and align code accordingly. Pseudocode is used for creating an outline or a rough draft of a program that summarizes a program's flow but excludes underlying details. Pseudocode acts as the bridge between the programmer's brain and the computer's code executor that provides the ability to plan instructions that follow a logical pattern without including all the technical details. Pseudocode is a great way of getting started with software programming as a beginner without worrying about coding syntax. Pseudocode helps both programmers and non-programmers agree about the program's goal and the basics of how the task should be done. Here's one example of pseudocode written to check if the user entered an odd or even number. The next example displays the pseudocode written in C++. There are many advantages of using pseudocode over flowcharts. The main benefit of pseudocode is that it's simple and explains exactly what each line of an application should do. The coder can focus more on logic than on program language syntax. Removing the distractions of coding when using pseudocode makes the code development stage easier. Words and phrases in pseudocode represent lines of basic computer operations that simplify translation from the pseudocode algorithm to the specific programming language. Pseudocode allows programmers working in different computer languages to interact with each other. Pseudocode can be reviewed by different development groups, easier than real code. Pseudocode is easier for non-programmers to read and enables quick and easy translation to any computer language. Writing pseudocode is more concise and easier to modify, so changes to the design can be easily incorporated. And lastly, unlike some flowcharts, pseudocode is usually less than 1 page. In this video, you learned that organizing and planning out software design enables programmers to write cleaner and more reliable code. And organized code is very important from a readability, maintainability, and scalability standpoint. Two main methods of organizing and planning software code are by developing flowcharts or writing pseudocode. A flowchart is a pictorial representation of an algorithm, showing the steps as boxes of various kinds, connected by arrows that indicate their order. And the main goal of pseudocode is to explain exactly what each line of a program should do, making the code construction phase easier for the programmer. Welcome to Branching and Looping Programming Logic. After watching this video, you will be able to describe the two types of programming logic, define Boolean expressions and variables, and list the differences between branching and looping. There are two major types of programming logic, branching and looping. Both types use Boolean expressions and variables. A Boolean expression is a type of programming statement with only two values, either true or false, and variables have assigned values that are passed into a function or subroutine within a more extensive program. Computers use Boolean logic to make decisions. The computer takes one action if a Boolean expression is true and a different action if the expression is false. Typically, a program consists of instructions that tell the computer what to do and data that the program uses when it is running. A variable has a value that can change depending on conditions or information passed to the program. Boolean logic, along with variables, form the basis of programming. Branching logic is where a computer makes a decision following a different set of instructions depending on whether certain conditions are met during the program's execution. Each possible code pathway creates another branch. The branch of code that runs depends on the values assigned to the parameters of the branching procedure, and there is no limit to the number of branches to implement complex logic. The values of these parameters may be input by the user or generated by the output from a previous procedure. Branching contains constructs that occur and are processed to determine the path a program takes when running. Branching statements, also known as constructs, allow the execution flow to jump to a different part of the program. The common branching statements used within other control structures include if then else, switch, and goto. The if statement is a decision-making construct that guides a program to make decisions based on specified criteria. The if statement executes one code set when a specific condition is met, true, or another code set if the condition is not met, false. The if-then-else is a conditional construct that executes its substatement, which follows the then keyword. This only occurs if the provided condition is true. The if-else statement extends the if statement by specifying an action if the if, or true-false expression, is false. With the if-else statement, the program will execute either the true code block or the false code block, so something is always performed with an if-else statement. In computer programming languages, a switch statement is a type of selection control mechanism used to allow the value of a variable or expression to change the control flow of program execution via search and map. Go-to is a statement found in many computer programming languages that performs a one-way transfer of control to another line of code. In contrast, a function call typically returns control. Now, let's look at the logic of looping programming. A loop is a sequence of instructions that continually repeats until reaching a specific condition. Typically, a particular process is performed, such as retrieving and changing data, and then some conditions are checked, such as whether a counter has reached a prescribed number. If it has not, the next instruction in the sequence is to return to the first instruction in the series and repeat the sequence. If the condition is reached, the next instruction falls through to the next sequential instruction or branches outside the loop. A loop is a fundamental programming idea commonly used in writing programs. There are three basic loop statements: while, for, and do while. In a while loop, a condition is evaluated before processing the body of the loop. If a condition is true, then and only then the body of the loop is executed. In a for loop, the initial value is performed only once. Then the condition tests and compares the counter to a fixed value after each iteration, stopping the for loop when false is returned. And in a do-while loop, the condition is always executed after the body of a loop. It is also called an exit-controlled loop. In this video, you learned that there are two major types of programming logic: branching and looping. Both types of logic use Boolean expressions and variables. Boolean expressions have only two possible values, either true or false, and variables have assigned values that are passed onto a function or subroutine within a more extensive program. Variables have values that can change depending on conditions or information passed to the program. And branching is deciding what actions to take, while looping is deciding how many times to perform a certain action. Welcome to Introduction to Programming Concepts Part 1. After watching this video, you will be able to describe the purpose and use of identifiers in programming, and describe the purpose and use of containers in programming. To fully understand software programming, there are some fundamental programming concepts you need to know first. The first concepts you will look at are identifiers. Software developers use an identifier to reference a program component, such as a stored value, a method, an interface, or a class, by assigning a custom named label to it. If the identifier stores data, then the data values in the program can be one of two types, either a constant or a variable. A constant is a data item whose value does not change within a program. This could be a numerical constant, such as the mathematical value of pi, or it could be a text string that remains constant, such as a player's name within a game. Constants are also referred to as named constants. You assign a value to a constant when you define it. For example, you might want it to refer to a numerical value within your program, such as pi, or a cost price, or a rate of tax, and then, rather than repeatedly retyping the same numerical value, you can just declare a constant for the value instead and name it something meaningful like pi_value, or cost_price, or tax_rate. There are a couple of major benefits to using constants in your programs. One is for ease of readability in your code, and the other is that if the specified value changes in the future, you only need to change it once on the constant, rather than finding every instance of that numerical value within your code and changing it. The other type of identifier used in programming is a variable. As the name suggests, this kind of identifier is not constant. Its value can change during the program's execution, such as a user entering their age in an application or a high score in a game. Variables can be strings of text, numerical values, or any other type of data. Using a variable as an identifier is a useful way to refer to program items that are unknown to you, such as a user name, a service, or a file name, for instance. If you don't use a variable, then you will need to hard code all the names and values in your program, which is not considered best practice. Variables can be declared and assigned a data type and initial value as they are defined, or you can decide not to assign an initial value when you define a variable and instead have the value assigned later by instructions within the program. In addition to the identifier data structures already discussed, there are also special kinds of identifiers that can reference multiple elements in a program, and these are referred to as containers. Being able to specify multiple elements means that you don't have to create a variable for every individual element. This makes it faster and more efficient. For example, if you only want to store 6 numerical integers, then you could argue that you could just create 6 variables, one for each. But what if you need to store 1,000 integers or more? In such a case, defining 1,000 variables would obviously be an unwieldy and inefficient programming technique. So in this case, you would use a container. There are 2 types of containers to specify multiple elements: arrays and vectors. The simplest of these container types is an array. In an array, a fixed number of elements of the same type are stored in sequential order starting from index 0. When you declare an array, you specify the data type of the values it contains, such as an integer, or Boolean, or a string, and then the maximum number of elements it can contain. The syntax for declaring an array is to specify the data type first, then the name of the array, then the maximum size of the array in square braces. In contrast to arrays that have a fixed size, vectors have a dynamic size, and they will automatically resize themselves as you add elements to them or remove elements from them. For this reason, you may also see them referred to as dynamic arrays. Because they are dynamic in nature, vectors take up more memory space than arrays, and their elements also take a little longer to access than elements in an array, as they are not stored in sequential memory locations. The syntax for declaring a vector is to specify the container type of the vector first, then specify the data type in angle brackets, then the name of the array. Note that because it is a vector, you do not need to specify a maximum number of values it can contain because the size is not fixed, it is dynamic. In this video, you learned that software developers use an identifier to reference a program component. If an identifier stores data, then it can either be a constant or a variable. A constant is a data item whose value does not change within the program. A variable is not constant, it can change during the program's execution. In an array, a fixed number of elements of the same type are stored in sequential order, starting from 0. And vectors have a dynamic size, and they automatically resize themselves as elements are added or removed. Welcome to Introduction to Programming Concepts, Part 2. After watching this video, you will be able to describe the purpose and use of functions in programming, and describe the purpose and use of objects in programming. Next, let's look at the fundamental concept of functions. Functions are a consequence of the modular programming software development methodology that encourages the separation of a program into multiple modular components, where each performs a specific task within a program. So, a function is essentially a piece of structured, standalone, and reusable code that will perform a single specific action. This enables software developers to take a substantial, complex program and divide it into smaller, more manageable, and focused pieces. Although some programming languages may refer to them as something else, such as subroutines, procedures, methods, or modules, most modern programming languages refer to them as functions. Functions take in data as an input, then process the data, and then return the result as an output. There are essentially 2 types of functions. Standard library functions are the built-in functions provided by the programming language. Common examples include the if, else, while, and print functions. But programming languages also allow you to write your own functions. And once you've written a function, you can use it over and over again. The way that the blocks of code that make up a function are identified is different across programming languages. Some use braces, some use begin and end statements, and others use indentations, for example. There are a few steps to using functions. The first thing you need to do is define or create a function. When you define a function, you provide a function keyword, then give the function a unique name, and you provide the statements that make up the body of the function. Once a function has been defined, it then needs to be called or invoked. When you call a function, the specified actions within the function are performed using any specified parameters. While defining and calling functions are common to all programming languages, some programming languages, such as C and C++, also require you to declare a function. Next, let's look at the concept of objects. Understanding what objects are is key to understanding object-oriented programming. Object-oriented programming, or OOP, is a programming methodology that is focused on objects rather than functions, which is what procedure-oriented programming is focused on. The objects themselves will contain data in the form of properties or attributes, and code in the form of procedures or methods. The key distinction between the two methodologies is that where procedural programming uses methods to operate on separate data structures, OOP packages them both together so an object operates on its own data structure. Consider the real-world objects in your life, such as your car, bike, TV, or your washing machine, and ask yourself the following two questions. What states can the object be in, and what behaviors can the object perform? When you think about your answers to these questions, you will find that the answers to these questions vary across the objects. More complex objects will typically have more potential states they can be in, and will be able to perform more behaviors. In programming, a software object is similar to a real-world object, conceptually speaking, in that they too consist of states or properties and behaviors or methods. Software objects can be anything, such as a Windows service, a user account, a database table, or a system folder. Objects store their properties in fields, referred to as variables in some programming languages, and expose their behaviors through methods, referred to as functions in some programming languages. In this video, you learned that a function is a piece of structured, standalone, and reusable code that will perform a single specific action. The defining and calling of functions is common to all programming languages. Object-oriented programming is a programming methodology that is focused on objects rather than functions. And software objects consist of properties and methods. Welcome to Types of Data, Sources, and Uses. After watching this video, you will be able to identify different types of data, recognize data sources, and list some of the ways to use data. Today's world is full of data, but how do we define data? Data is any set of characters that is gathered and translated for some purpose, usually research or analysis. Data can consist of facts, observations, perceptions, numbers, characters, symbols, images, audio, text, or any combination of these. There are multiple types of data, including these common types: single character, Boolean, true or false, text, string, number, integer or floating point, picture, sound, and video. Data can be classified as primary or secondary. Primary data is generated directly by the individual needing the information. Secondary data is information that has already been gathered for another purpose. Raw data, also known as primary data, contains numbers, instrument readings, and figures collected from sources. In the context of an examination, the raw data might be a raw score. When processed, this raw data output can be analyzed and studied. Data and information are collected on a computer using a hard drive or another storage device. Data is stored in binary form using zeros and ones. There are several forms of data. Personal data is anything specific to an individual, like name, demographics, location, address, and other identifying information. Transactional data is anything that requires an action to collect the information. Clicking online advertisements, making an online purchase, and visiting certain websites are all forms of transactional data. Transactional data is crucial for businesses, helping them to expose variability and optimize operations. Web data refers to any data pulled from the internet for research or other purposes. Web data is a catch-all for public-facing information on the internet. In other words, not stored in a private database. Companies can use this information to monitor competitors, track potential customers, keep track of channel partners, generate leads, and build applications. Sensor data is information produced by objects and is often known as the Internet of Things. This type of data covers everything from a smartwatch measuring heart rates and temperature to a building with external sensors that measure the weather or turn on lights when motion is detected. Currently, sensor data's primary use is to help optimize processes. The level and rigidity of the data's structure determine the information's classification. Data can be structured, semi-structured, or unstructured. Databases store and display structured data in rows and columns similar to an Excel or Word table. The information has a well-defined schema and a rigid structure. These characteristics make relational databases, which store data in tables, ideal for structured data. Microsoft SQL Server, IBM DB2, and Oracle databases are forms of structured data. Semi-structured data has some organizational properties. However, the information does not collect in the rows and columns required by a rigid tabular schema. Instead, semi-structured data is organized into a hierarchy using tags and metadata and is stored in non-relational databases. Unstructured data is information that does not have an identifiable structure or specific format, sequence, semantics, or rules, and is often stored in NoSQL databases. The most common examples of unstructured data include text like Word documents and emails. However, unstructured data also includes images, audio files, and log files. MongoDB, HBase, CassandraDB, and Oracle NoSQL DB are forms of semi-structured and unstructured data. A multitude of data sources are available today, including internal organizational data stored in a database, publicly available data like weather, financial, and government, APIs and web services, websites, data streams and feeds, social platforms, and devices with sensors. This data is stored, processed, and made available for analysis, providing businesses with insights into their performance. Data sources can be internal or external. When an individual collects data from reports and records supplied by an organization, group, or other entity, this is known as internal sourcing. Examples of internal sources include accounting information, order processing details, payroll, and shipping information. When users collect data from sources outside an organization, group, or other entity, this is known as external sourcing. Examples of external sources include social media feeds, weather reports, government information, and research. Companies use internal and external data to scale up businesses, understand customer purchasing trends, and increase overall productivity. In this video, you learned that data is information like facts, observations, perceptions, numbers, characters, and images that are processed to become meaningful. For example, upper and lower case letters, numerals, and special characters. Data can be structured, semi-structured, or unstructured depending on the level and rigidity of its organization. Different data sources offer different types of data. For example, data from social media can be unstructured or semi-structured. And data is essential to many organizations and is used to manage information from accounting to shipping and routing. Data is generated constantly in today's world, 24 hours a day, 7 days a week. Welcome to Database Fundamentals and Constructs. After watching this video, you will be able to describe the fundamentals of databases, recognize the need for databases, and identify database constructs. A database is a computerized record-keeping system that stores large quantities of information and provides tools for evaluating and manipulating data. Database users can search, research, analyze, compare, change, and manipulate information within a database with optimal speed and minimal processing. A database is built and maintained using a programming language. The most common is SQL, but SQL has multiple flavors, depending on the type of database. And there are two types of databases, relational and non-relational. A database has four main components. A schema is a collection of one or more tables of data. A database can contain one or more schemas. A table is one or more columns of data, like in an Excel spreadsheet. A table can have two or more columns depending on the type of stored data. A column is a pillar of information containing one or more data values, including dates, numeric or integer values, and alphanumeric values. And a row is horizontally formatted information, like rows in an Excel spreadsheet. Typically, there may be hundreds or thousands of rows of data in a table. Additional terms associated with a database are queries and constraints. A query can either be a request for data results from a database, action on the data, or both. A query can also provide an answer to a simple question, perform calculations, combine data from different tables, and add, change, or delete data from a database. Constraints are made up of primary keys, which are the rules enforced on the data columns, certifying that the values in any column row do not repeat. Constraints limit the type of data that can go into a table and ensure the data's accuracy and reliability in the database. When setting up a database, it is usual to define a set of queries used to answer questions from the data in the database. The output produced by the database is called a report. Queries are an important part of using a database. A query is a way of requesting information from a database, and there are two types of queries, select or action. A select query retrieves data, and an action query requests additional actions to be performed on the data, like deletion, insertion, and updating. A frequently used query is the create table statement that creates a new table in the database. The column parameters specify the names of the columns of the table. The data type parameter specifies the type of data the column can hold. For example, varchar, integer, date, and so on. Another common query is the select statement that retrieves records from a database table according to clauses. For example, from and where that specify criteria. The select clause specifies one or more columns to be retrieved. To specify multiple columns, use a comma and a space between column names. To retrieve all columns, use the wildcard star or asterisk. The from clause specifies one or more tables to be queried. Use a comma and space between table names when specifying multiple tables. And the where clause selects only the rows in which the specified column contains the specified value. The value is enclosed in single quotes, for example, where last underscore name equals Smith. The semicolon is the statement terminator, and if only one statement is sent to the back end, the statement terminator is not necessary. However, it is a best practice to include the statement terminator regardless. Some common relational database constraints are primary and foreign keys. A primary key is the column or columns that contain values that uniquely identify each row in a table. In this figure, the primary key is ID. A database table must have a primary key defined to insert, update, restore, or delete data from a table. A foreign key is a column or set of columns in a table whose values correspond to the values of the primary key in another table. In this figure, the foreign key is class ID. For each foreign key value, a row in the related table must exist with the same primary key value. A database management system, or DBMS, has the following characteristics. It provides security and removes redundancy, has the same self-describing nature as a database system, grants program data independence, meaning there is insulation between programs and data abstraction, supports multiple views of the data, shares data and multi-user transaction processing, allows entities and relations among them to form tables, follows the atomicity, consistency, isolation, and durability or ACID concept. And a DBMS supports a multi-user environment that allows users to access and manipulate data in parallel. Many industries use databases, including universities, banking, and telecommunications. A flat file database, also known as a text database, stores data in a single table and can be set in various application types, including HTML documents, simple word processors, or worksheets in spreadsheet applications. The tables within a flat file database can be sorted based on column values. Flat files serve as a solution for simple database tasks. A database is another method of storing information. A database uses multiple table structures, cross-referencing records between tables. A database can store information in multiple table structures, with records organized in columns and rows, with each column containing a single piece of data. Finally, databases are faster, more efficient, and more powerful than flat files. Here is an example of a flat file database that stores information about students in a school, identifying their form and form teacher. There are two issues with trying to store this data in a flat file database. Redundant data. Some data can be stored more than once, wasting storage space and causing inconsistencies. And data inconsistency. Multiple tables within a database deal with the same data, but may receive it from different inputs. Data redundancy can compound data inconsistency. In a relational database, data is stored in multiple files linked by common fields. Here is the same data stored in two files in a relational database. Relational databases have two important advantages over flat file databases. Control over redundant data. Wherever possible, storing data once eliminates the wasting of storage space. And data consistency. Because each data item is stored only once, there cannot be two different values, so the data will always be consistent. Here are some of the many differences between flat files and databases. Flat files do not support multi-user access, while multiple users can access a database at one time. Databases with permissions and privileges are more secure than flat files. Flat files are usually one file, and databases can have a large amount of records. A database can contain multiple databases within it, unlike flat files. Searches and other transactions within flat files are faster than in databases. Most databases support complicated transactions, flat files do not. And flat files are easy to set up without needing specific expertise. Special training may be required to configure a database. In this video, you learned that a database is a computerized record-keeping system to store large quantities of information. A database provides tools that give the ability to search through stored data for specific bits of information. When creating a database, organize data so that the computer can analyze and search it automatically. Databases include schemas, tables, columns, and rows. Databases also contain queries and constraints. A query is a way of requesting information from the database, and constraints are the rules that apply on the type of data in a table. And there are two types of databases, flat files and relational databases, and each has advantages. One of the main differences is a flat file has a single record, while a database can have multiple records. Welcome to Database Roles and Permissions. After watching this video, you will be able to describe how database permissions work, explain how permission commands enforce database security in a multiple-user database environment, and identify the benefits of roles in a database. Permissions are authorizations enabling a particular user to access a specific database or database table. There are three main types of database permissions in decreasing scope: database, system, and object. Database permissions and privileges execute a specific type of SQL statement or access a second person's object. Database privilege controls the use of computing resources and does not apply to the database administrator or DBA. System permission is the right to perform an activity, such as to create, alter, or drop on a specific type of object. The ability to add or delete columns and rows of any table in a database is an example of system permission. Object privilege is the right to perform a specific action on a particular table, function, or package. For example, the right to delete rows from a table is an object privilege. This privilege allows the user to insert, delete, update, or select the data in the database object. An object's owner has all object permissions for that object, and those permissions cannot be revoked. The object's owner can grant object permissions for that object to other database users. A user with admin privileges can grant and revoke object permissions from users who do not own the objects on which the permissions are granted. Permission commands enforce database security in a multiple-user database environment. There are three main permission commands: grant, revoke, and deny. The grant command provides user access rights or permissions to the database objects. This command also allows users to grant access rights to other users. Here is the syntax for the grant command. The revoke command removes user access rights or permissions to the database objects. Here is the syntax for the revoke command. And the deny command denies permission on an object and prevents the principal from gaining grant permission based on membership in a group or role. Here is the syntax for the deny command. Only a database administrator or the owner of a database object can provide or remove permissions on a database object. A database role is a collection of any number of permissions that can be assigned to one or more users. Roles allow you to grant and manage sets of permissions for various categories of users rather than grant those permissions to each user individually. The DBA maintains user roles and applies them to the entire server and not to an individual database file. The public role sets the basic default permissions for all users. Every user that is added to a SQL server is automatically assigned to the public role, so no additional actions are needed. Database roles are applied to an individual database. The table contains a list of some of the more common user roles and their associated access levels. Database roles can be granted to set system or schema object permissions to other roles. However, a role cannot be granted to itself and cannot be granted circularly. For example, role A cannot be granted to role B if role B has previously been granted to role A, to any database user, to a user as either enabled or disabled. A user's security domain includes the permissions of all roles currently enabled for the user and excludes the permissions of any roles currently disabled for the user. Roles can be enabled or disabled to provide selective availability of permissions. Indirectly to a role, this means that the role can be explicitly enabled or disabled for a user. However, by enabling a role that contains other roles, you implicitly enable all indirectly granted roles of the directly granted role. And roles can be granted or revoked at any time. In this video, you learned that permissions provide the authority to access a database, tables, objects, and other system resources in a specified manner to allow selection, insertion, or modification of data rows. A database role is a collection of any number of permissions that can be assigned to one or more users. Roles allow granting and managing sets of permissions for various categories of users rather than granting those permissions to each user individually. And roles can be granted and revoked at any time, allowing for more flexibility in maintaining a database. Welcome to Data Types. After watching this video, you will be able to define the different types of databases, identify relational databases, and describe non-relational databases. There are 3 types of data: structured, semi-structured, and unstructured. Structured data is generally tabular data that is represented by columns and rows in a database. The databases in this form are called relational databases. The mathematical term relation is specific to a formed set of data held as a table. In structured data, all rows in a table have the same set of columns. One example of structured data is structured query language or SQL programming language. Here is an example of semi-structured data. Semi-structured data has some structure to it and consists of documents held in JavaScript Object Notation or JSON format. This type of data also includes key value stores and graph databases. Unstructured data contains a lot of types of information and is not organized in a predefined manner or data model. This type of data is usually text-heavy but may contain numbers, dates, and other characters. Videos, audio, and binary data files might not have a specific structure and are considered unstructured data. Some specific examples of unstructured data types are text files and documents, server website application logs, images, video files, emails, social media data, audio files, and sensor data. There are 2 types of databases, relational and non-relational. A relational database is structured to recognize relations among stored items of information. A non-relational database stores data in a non-tabular form and tends to be more flexible than the traditional SQL-based relational database structures. A relational database, or a SQL database, stores data in tables that contain rows and columns. The rows in a database are called records. Relational databases store related data information with a defined relationship between database tables used with other datasets. A relational database works by connecting multiple data tables with unique identifiers known as keys, which allow for the connected relationship between tables. Relational databases apply to structured data sources and have connections within the database. Examples of relational databases include MySQL, IBM DB2, Oracle, SQLite, Postgres, and MS SQL. A non-relational database is a non-SQL database, also known as a NoSQL database, that stores unstructured data. Non-relational databases are not restricted to data being in tables and therefore differ from structured relational databases in that there are no tables, rows, or keys. Instead, a range of different types of data can be stored in different formats using specialized frameworks. Non-relational databases are ideal for storing and combining big data and unstructured data, offering more flexibility in working with this type of data over relational databases. Examples of non-relational databases include MongoDB, Apache Cassandra, Redis, Couchbase, and Apache HBase. Non-relational databases permit storing store data in a format that more closely meets the original structure. There are many types of data stores, but the following are encountered most often: document data stores, key value stores, column-oriented databases, and graph databases. A document data store handles a set of objects, data values, and name string fields in an entity referred to as a document. These data stores generally store data in the form of JSON documents. Here is an example of the document data store model. A key value store is a large hash table with each data value associated with a unique key to collect data by using a correct hashing function. The hashing function is preferred. It provides an even distribution of hashed keys across the data storage. Key value stores are highly suitable for applications operating simple lookup functions using the value of a range of keys. A columnar or column family data store constructs data into rows and columns. The columns are divided into groups known as column families. Each column family consists of a set of columns that are logically related and are generally retrieved or manipulated as a unit. Within a column family, rows can be sparse and new columns can be added dynamically. A graph data store handles two types of information, edges and nodes. Edges point out the relationships between these entities, and nodes represent entities. The aim of a graph data store is to allow an application to efficiently perform queries that traverse the network of edges and nodes, and to inspect the relationships between entities. In this video, you learned that there are three types of data. Structured data is organized in a relational database, semi-structured data is partially organized, and unstructured data is based on simple character and binary data. Relational databases store data in rows and columns, and non-relational databases do not have a predefined manner or data model. There are different NoSQL databases for storing non-structured data. And non-relational databases store different types of data in various formats using specialized frameworks. Welcome to Interfacing with Databases. After watching this video, you will be able to describe the working principle behind interfacing a database, and identify the four main ways of interfacing with databases. A database interface enables users to input queries to a database without using the query language itself. Interfaces are an electronic form that contains what kinds of queries users can make. Web-based forms are becoming increasingly common with the popularity of MySQL, but the traditional way to do it has been local desktop applications. Mobile applications can also be designed to provide a friendly way of accessing data. The application poses a query to the database system with the help of SQL. There, the corresponding result set or answer is prepared, and with the help of SQL, given back to the application. This communication takes place interactively, or can be embedded into another language. There are two types of database interface: interactive SQL, which can be used from a terminal, and embedded SQL, which can be embedded into another language or host language, which might be used to create a database application. A database can be accessed in a variety of ways: direct or manual access, programmatic access, user interface or utility access, and query or report builders. Direct access or manual access is when a user enters SQL commands and selects a menu to access the tables in a database. Users can directly access database tables to view or change data. Direct access works well when it only needs to be accessed by a few users and with a database that is stored locally or on a local area network. The following figure is an example of editing a table directly in Microsoft Access database. Programmatic access uses a programming language to access a database that enables the data to be used in more ways. This type of access is safer than using direct access. Oracle databases support access from many languages, including Oracle PL/SQL, which combines a procedural language with SQL, Oracle JMS, a Java Application Programming Interface API, ProCC, C++, and others. Depending on the database and programming language, it might be necessary to perform a query using a supported language and then connect to the result with the language you prefer. This table showing product ID, product name, and price is an example of connecting to SQL Server from a Python program and extracting data and displaying information. The server name, database name, and table name are given in this code example. A database, like Microsoft Access, is designed to permit database access through its user interface. With SQL databases, an optional user interface may be needed to make usage easier. Oracle offers MySQL Workbench as a graphical user interface, or GUI, for use with MySQL. A database management system, or DBMS interface, is a user interface which allows for the ability to input queries to a database without using the query language itself. DBMSs provide the following benefits: web-based interfaces for web clients or browsing, form-based interfaces. A GUI displays a schema to the user in diagrammatic form. The user can specify a query by manipulating the diagram. GUIs utilize both menus and forms. Most GUIs use a pointing device, such as a mouse, to pick a certain part of the displayed schema diagram. And natural language interfaces have their own schema, like a database conceptual schema that accepts user requests and tries to interpret them. Search engines use a natural language interface to enter and retrieve information. This image is querying a table in MySQL using the MySQL Workbench interface. A query is used to find specified data in a database by using the select statement. Some databases, like Microsoft Access, have built-in query and reporting functions. Query Builder provides a GUI for creating SQL queries and is designed to enhance productivity and simplify SQL query building tasks. Users can drag multiple tables, views, and columns into a visual designer to generate SQL statements. The Query Builder can perform the following tasks: work with a graphical representation of a query or SQL code. Query Builder includes a pane that displays a query graphically and a pane that displays the corresponding SQL text. Join related tables. When adding more than one table to a query, Query Builder automatically determines how the tables are related and constructs the appropriate join command for data extraction. Query or update databases. Returns data using select statements to create queries that update, add, or delete records in a database. And view and edit results that are immediate. Some examples of query builders are Haryo Visual SQL, DBForge Query Builder for SQL Server, Active Query Builder, FlySpeed SQL, Query DB Viz, and Query Builder. This image displays a query built using FlySpeed Query Builder, where the user selects the tables and the columns he needs in each table. In this video, you learned that a database interface enables interaction between the user and a database management system. And there are many ways to access a database, but the common ones are direct access, programmatic, user interface, and query and report builders. Welcome to Database Management. After watching this video, you will be able to describe how databases are managed, identify the 3 major SQL command categories and what each one does, and explain how to input and extract database information. Databases are managed with structured query language, or SQL, commands and queries. A database query refers to the retrieval and management of data or information from a database. A database query generates data of different formats according to function. Query commands perform the retrieval and management of data in a relational database. With SQL commands, you can provide access to data in relational database management systems, describe the data, manipulate the data, create and drop databases and tables, view stored functions and procedures in a database, and set permissions on tables, procedures, and views. SQL commands can be grouped into the following categories based on functionality: data definition language, or DDL, data manipulation language, or DML, and data control language, or DCL. DDL consists of the SQL commands used to define the database schema. DDL commands enable you to create, modify, and delete database structures, but not data. Common DDL commands include the following: the create command that creates the database or its objects, such as tables, indexes, functions, views, store procedures, and triggers. The drop command that deletes objects from the database. The alter command that alters the structure of the database. and the truncate command that removes all records from a table, including all spaces allocated for the records. This is an example of a drop command where table is the name of the table to be deleted. DML includes most of the SQL commands that deal with the manipulation of data in the database. The DML command is the component of the SQL statement that controls access to the data and to the database. Common DML commands include the following: the insert command that inserts data into a database table, the update command that updates existing data within a database table, the delete command that removes records from a database table, and the select command that retrieves records from a database table according to clauses. For example, from and where that specify criteria. This is an example of the delete command. DCL includes commands which mainly deal with the rights, permissions, and other controls of the database system. DCL commands create and modify the structure of objects in the database. DCL commands include the following: the grant command that provides users with access permissions to the database, and the revoke command that withdraws users' access permissions given by the grant command. Here is an example of the revoke command. One way of inserting data into a database is through queries. Some of these query commands include create database, create table, and insert into table. Here is an example of inputting data into a relational database using these commands. The other way to input data is by importing it from external sources into a database using software tools and utilities. This example shows inputting an Excel data source into a SQL Server database. Importing multiple worksheets from an Excel workbook into a SQL Server database typically involves using one of the following software application tools: SQL Server Import and Export Wizard, SQL Server Integrated Services, or SSIS, or the Open Row Set function. Importing data directly from Excel files using the SQL Server Import and Export Wizard involves following a sequence of dialog boxes through a series of well-defined steps. The settings can be saved as an SSIS package that can be customized and reused later. The Open Row Set function imports data directly into SQL Server from Excel files by using the Transact SQL Open Row Set or the Open Data Source function. This process is called a distributed query. There are two ways to extract data from a database: queries and report builders. A query is a question defined and sent to the data source to retrieve the data. Here is an example of the select command to retrieve data from a table. Reports offer a way to view, format, and summarize the information in a database. A database report is the formatted result of database queries that contains useful data for decision-making and analysis. Reports can be a simple list of phone numbers of all contacts, or more complex, like a summary report on the total sales across different regions and time periods. There are many data reporting tools that are popular on the market today, including ClearPoint, SAP Crystal Reports, and Jaspersoft Reporting. In this video, you learned that SQL commands are the instructions used to communicate with a database to perform tasks, functions, and queries with data. SQL commands can be used to search the database and perform other functions like creating tables, adding data to tables, modifying data, and dropping tables. SQL commands are grouped into three major categories depending on their functionality: DDL commands that are used for creating, modifying, and dropping the structure of database objects, DML commands that are used for storing, retrieving, modifying, and deleting data, and DCL commands that are used for providing security to database objects. And data is input into a database using queries: create database, create table, and insert into table. And data is extracted by using queries and reporting software tools, such as ClearPoint, SAP Crystal Reports, and Jaspersoft Reporting. Welcome to Backing Up Databases. After watching this video, you will be able to define the two types of database backups and explain the differences between the two, describe why database backups are important, and identify the four main physical backup methods. Backing up a database protects data, whether it is a person's or an organization's, from disaster and allows for restoring information when necessary. A backup, usually performed by a relational database management system or database manager, replicates a database or database server that can be saved either locally or on a backup server. Database backups are categorized as either physical or logical. A logical backup is called a database dump, and a physical backup is completed through a type of backup software. Some examples of backup software include ScaleGrid, CyberShield, Backup Ninja, and SQL Safe Backup. Physical database backups are copies of directories and data files, including data controls, transaction files, and archived logs. This information is necessary to perform a full database restoration with minimal application errors and data loss. The backups, which can be full or incremental copies of the physical backup, should always be stored in separate, dedicated storage space, such as a disk, tape, or in the cloud. A logical database backup contains copies of information about a database, such as tables, schemas, and procedures. This data is commonly exported as binary files using export-import tools. Logical backups are helpful when restoring or moving a copy of the database to another environment. Physical backups are simple and fast, regardless of the data format. The physical backup is a mirror copy that is loaded to another device. The downside to physical backups is that this type is typically used only to recreate the system at restoration and cannot do a full restoration if there are any missing files. In logical backups, only a selected set of data is backed up, saving time and storage. The downside is that there is no file system information, which complicates the restoring process. There are four database backup methods available: full, differential, incremental, and virtual. A full backup stores a copy of all files following an automatic preset schedule. Typically, files are compressed to save space, but a lot of storage space may still be needed. A differential backup simplifies recovery, requiring only the last full backup and the last differential backup to create a complete database recovery. An incremental backup saves storage by backing up the files generated or updated since the last backup. And a virtual full backup uses a database to track and maintain backup data, helping to avoid the pitfalls of other methods. Having a backup system allows access to data without time or location constraints. Multiple copies of data are kept secure at different locations, ensuring all information is preserved. Online backup services, such as cloud storage, offer additional protection for emergencies, such as natural disasters. Automatic backup and detailed file management enhance processing and recovery without needing manual effort. Having an online server backup saves effort when setting up a system and shifts the focus to database security, allowing the efficient use of available resources that saves time and money. A prompt and reliable backup solution enables businesses to avoid a loss of reputation and legal action if valuable information is lost. After making a solid plan and completing initial work, the database administrator should properly manage backups by automating backups, monitoring backups, keeping backup logs and catalogs, maintaining the database catalog, setting up dependencies, and validating backups. There are a multitude of ways to store data: online, USB drives, external hard drives, and local area networks. In this video, you learned that a logical backup contains copies of information about a database, and physical backups are copies of directories and data files, including data controls, transaction files, and archived logs. Backup copies allow data to be restored from an earlier point in time to help the business recover from an unplanned event. Storing the copy of the data on a separate medium is critical to protect against primary data loss or corruption. And there are four main methods of backing up a database. Full, which is a copy of all files following an automatic preset schedule. Differential, which includes the last full backup and the last differential backup. Incremental, which saves storage by backing up the files generated or updated since the last backup. And virtual, which uses a database to track and maintain backup data.